So, good afternoon, everyone. On behalf of the sir, am I audible?
Yes, sir.
Yes, sir.
Good afternoon, everyone. On behalf of the Department of Civil Engineering, Ramchandra College of Engineering, I extend a warm welcome to all of you on this final day of the Faculty Development Program on disaster risk reduction through sustainable infrastructure. First of all, allow me to introduce myself. I am Y. Sombabu, uh, Assistant Professor in Civil Department and co-coordinator of this FDP. It has been an honor to host such as an engaging and insightful program, bringing together experts, researchers, and participants from the diverse fields. It has been an incredible journey over the past few days, filled with the knowledge sharing, insightful discussions, and meaningful interactions. As we conclude this program today, we are confident that the sessions have provided valuable perspectives on the disaster risk management and sustainable infrastructure. Today, we have an exciting lineup of three sessions, starting from 2 o'clock, with some of the most experienced speakers sharing their expertise. We encourage you to actively participate and making the most of this final opportunity to engage with the experts and your peers. Thank you once again for your dedication and your patience throughout this FTP. Let's make this a concluding day a memorable and impactful one. I would like to take a moment to warm welcome HOD of Civil Department, Dr. K. Sundar Kumar, to the today's sessions. Dr. Sundar Kumar has been a key part of the organizing and coordinating this entire program, ensuring its smooth execution and support all participants throughout FTP. Now, I would like to take a moment to introduce our esteemed speaker for session 11. It is my honor and privilege to introduce our experienced speaker, Dr. Kalyan Kumar sir, who currently serves as an associate professor in the Civil Department of Civil Engineering at NIT Warangal, India. Dr. Kalyan Kumar holds BE in Civil Engineering from CBIT Hyderabad and MTech in Geotechnical Engineering from JNT Hyderabad and PhD in Civil Engineering with a specialization in Geotechnical Engineering from IIT Madras. Dr. Kalyan Kumar is an accomplished researcher and academician with over 66 publications, including 9 SCI, 60 national journals, 7 book chapters, and numerous conference contributions. His research interests span a wide range of critical areas, including seismic hazard analysis, soil dynamics, disaster management, and biomodification of fine-grained soils. He has successfully guided 3 PhD scholars with ongoing 3 members, 29 MTech students with ongoing 3 members, and 8 batches of BTech projects. Dr. Kalyan Kumar has led impactful research projects, including seismic hazard analysis of Warangal city. He has delivered expert talks at prestigious forums such as the Symposium of Geo Practices 2017 and 5-day faculty development program on geotechnical engineering NIT Warangal. Dr. Kalyan Kumar has also contributed significantly to the industry through the consultancy works worth approximately 50 lakhs and scoring the practical impact of his expertise. He has received the merit certificate from the Indian Geotechnical Engineer Conference 2009 and is an active member of professional organizations including the Indian Geotechnical Society and the Society of Earthquake Technology. Today, we are privileged to have Dr. Kalyan Kumar sir share his insights on GPR studies inside Rohtang Tunnel, which promises to be a profound learning experience for all us. Please join me in giving a warm welcome to Dr. Gonavaram Kalyan Kumar, sir.
Thank you, sir. Thank you very much, sir. Very nice introduction about things. And I think so. My voice is audible now, sir. Any problem is there?
Sir, no problem, sir.
Okay. So I'm sharing the screen, sir. Please let me know my screen is visible or not. This is my first slide, sir. Are you able to see
Yes, sir. Yes, sir.
about the Ramchandra College of Engineering?
Yes,
Ramchandra College
sir.
of Engineering.
Yes.
Yeah, slides are changing, sir.
Yes, sir. They are perfectly working, sir.
Okay, thank you, sir. Thank you very much, sir. Yeah, very good afternoon to one and all the participants and all those things. And first of all, I have to thanks to the Ramchandra College of Engineering for giving me this opportunity to give a inverted talk on in FDP on disaster risk reduction through sustainable infrastructures. So this is very nice introduction was given by Som Babu sir about me and all those things. See, yeah, I was completed in the year 2010 from IIT Madras PhD, and later I joined as a scientist in National Geotechnical Facility at Dehradun. There I was involved so many consultancy works and so many projects and all those things. Some of the projects only I am going to share with you about the disaster risk reduction point of view, because everyone knows about the Badrinath disaster. I think so. In the year 2013, it was happened. So cloud burst was happened. So much amount of rainfall and all those things. Badrinath area, so much amount of landslides and all those things are happen. And so that is the reason only we are submitting the project proposals and all those things. I can show the things. What are the areas were involved, and what are the equipments we are utilized to address that problems point of view and all those things. If you are having any queries, please, if any problem is there in my presentations or anything, please let me know. I will try my level best to clear the doubts of the participants and all those things. So this is the title of my project presentation: Disaster Advancement Studies using GPR. Initially, I'm discussing about the Rohtang Tunnel. Everyone knows about the Rohtang Tunnel. In the Pradhan Mantri Narendra Modi ji was taken it as a prestigious project, and he was inaugurated and all those things. So when we are there at that in Dehradun, the DST was addressed a problem. When they are constructing a tunnel, they faced it was not constructed by the individual contractors or anything. It was taken over by the BRO, Border Road Organization people, and they are hiring the contractors and all those things. And in there, ACOM is there, LNT is there. So many companies are there. So many different types of companies are involved in that work point of view, and they are constructing that length of, at that time the length of the tunnel is around 14 kilometers. So it was in the year 2010 itself. It was started in the around 10-15 years back itself, because if you are seeing the next slide, see, this much amount of overburdened soil was there. That means overburdened hillock is there and everything was there. At the bottom of this much amount of hilly terrain, at this terrain, they are laying a tunnel. If they are doing any supporting material or anything, if they are not providing means, everything will collapse. Whatever the money they spent and everything will collapse. The person's human life and everything, so many problems will be there. So they have to take care the utmost this one. And unfortunate thing is that this gave us the problem was arranged in the winter season doing construction in the Himalayan region, especially it is near the foothills of the Himalayas, I can say that one. Himachal Pradesh, not in the Dehradun region, that means Uttarakhand region and all those things. It is coming under to some other state, Himachal Pradesh. So we have to travel from the Uttarakhand to that place means around two terrains we have to cross by vehicle only. There is no trains, train facilities. There is bus facilities are also not that much comfortable. I can say that one. And so the DST was suggested that the BRO people are facing a problem, along with some other from Wadia Institute of Himalayan Geology person was also involved, A.K. Mahajan. Right now he moved to some central government institute in the Himachal Pradesh only, I think so. He was moved to the central government institute and all those things. So he was also involved in that in this project, in this never consultancy. No, I can't say that it is a consultancy work. It is a project. We are involved in that one. So we traveled with our GPRs and all those things, because for our institute, it is a government institute. So DST, Norwegian NGA, Norwegian government was sponsored a GPR for us. So we traveled with our GPR, and the Wadia people are purchased in a project separate GPR. So two different types of GPRs are there. I don't have that GPR. Stepwise GPR is there for them. We are having the antenna size type GPRs. Nowadays, so many GPRs are coming into the picture and all those things. What is the use of the GPR and all those things? I am going to share it with you coming slides. So what is the problem is that one, that is around 14 kilometers distance, the tunnel of the length of the tunnel. So they laid a tunnel up to the 10 kilometers. They are putting the so much ACOM people and LNT people, so many different companies are there. They laid a supporting material, they covered the tunnel, everything. They laid very nicely. But after 10 kilometers, what is happening is water is entering into the tunnel. So they are facing a problem. They are afraid. Because they don't know if they are going further means any water bodies are there, suddenly water will enter inside the tunnel. Whatever the money they spent, around hundreds of crores to construction of this tunnel. So up to that time, that moment, hundreds and thousands of crores they spent. Government of India was spent that much amount of money. The main agenda of this laying of this tunnel is that if you are there, if we are crossing this through this tunnel means you can reach a Pakistan border within half an hour. Within half an hour distance, half an hour time. Means whatever the goods we want to travel from the exchange of the goods and all those things, you can complete within half an hour time itself. Otherwise, it will take, you have to travel days together. You have to climb the hillock and you have to get down one hillock. Again, you have to climb another hillock and again you have to come down. Days together it will take. That this much amount of time if you are taking is, you can able to take that material safely or not. And so many problems are also will be there. So that's why the people are worrying about that one. So this was laid, that tunnel was laid and all those things. So now they laid up to the 10 kilometers and suddenly water is entering into inside the tunnel. They are worrying about that one. So government of India was gave this project to us, and we traveled to that place. And because we planned with, instead of GPR, we planned with MASW, but carrying the MASW is somewhat difficult. What is the meaning of MASW? I can show that one also coming slides. Some of the things, not in this area, some other area we conducted the MASW test and all those things also. Multi-channel analysis of surface waves. All these things are the non-destructive techniques. We are not giving any damage to any structure or any ground level or anything. We are not giving any trouble to the soil or any structure. That we have to address such type of problems only. We should not give any damage to any structures or any material or anything. Non-destructive techniques. So that is the main thing. So we traveled with the GPR because it's somewhat easy to carry the goods and all those things. Easy to carry only. It's not that much easy to perform the experiment and all those things. And all those. So what has happened is suddenly water is entering into the tunnel. So they are the government of India was requested to go and address the problem like that. So as a expert in that area. We travel to that place and we did the first of all we are understand the things. See, these are the people inside the tunnel. This is completely light is not there, nothing is there up to that moment. It means it is hardly before 1 kilometer, hardly 500 meters. Lightning is there, everything they arranged everything. But in this line, they are not provided any lights or anything. So we have to wear the jackets and all those things because vehicles are traveling continuously. So we should be somewhat safe about our things also. So we have to wear this type of jackets to people to identify the things. Some people are there, some vehicles are there here. They are doing some work like that and all those things. So we traveled up to this wearing this one. So they are working in the winter season in this location is not that much easy because water is too cold. It's the temperature is in the minus negative. It is going to the -2, -3, something like that. We have to wear the oxygen mask and all those things inside the tunnel, and we have to there. So up to that moment, so we are they are not providing. See, in the winter season, summer season, we are putting the ACs and all those things here in our house and everything. But there, it is not possible to. The cold is more. It is eating the bones. Whatever the bones are there, it is very dangerous. That much amount of cold. So there is no possibility to arrange these things and all those things, ACs and all those things. What the people are BRO people, military people, what they are doing is that they are having some kerosene is there. Some it is completely the forest area. They are bringing some sticks and they are putting some kerosene and for some fire, and it will run entire night. That because of that heat, whatever the heat is coming, we have to address, we have to survive continuously. We are taking the teas. So somehow I was habituated with the teas because of that reason, I don't know. Continuously 3 years I was spent there in the Dehradun region, and because of the cold and all those things. So temperature is very high. And anyhow, I am going to show the Dehradun region also, what are the some works I was involved in, all those things. So I will trying to share those things. So what we observed is that see, this is the actually GPR. Two antennas will be there. One is the transmitter, another one is the receiver. One antenna we are dragging just that one, and it is generating the waves. Another antenna will be there, that is the receiving the waves. So whatever the soil profile is there, instead of putting any borehole or anything like that, and we are taking that one and we are capturing that one and we are analyzing that waves, electrical waves. It's not something else. See, these type of observations you can observe. This is the very narrow depth only, hardly 2 meters depth is around 3 meters depth only. The waves will travel, not more than that. The antennas also I can show the coming slides. How that time this is the antenna different. What is the antenna I was used for the identification of that one and all these things. But we first of all we entered into the tunnel and we visited that one, how much amount of water is entering into the tunnel and all those things. We observed that one. So what we suggested that let it be like this. We want to go to the other side of the tunnel. Other side of the tunnel, any water bodies are there. How much? What is the fast of that water bodies? How much amount of water is passing nearby? That can and all those to observe that one point of view. We went to that side because it is not that much easy to travel that much amount of distance because vehicles will not travel. We have to go by climb. We have to climb only by walk only. We have to climb around 2 to 3 hours. We have to climb by walk. We have to go by walk only. We have to go there and we have to observe that one and we have to do some testing and we have to take that water bodies velocities and all those things, how much water bodies is there and all those things. And we have to coming back means again 3 hours it will take. That means that hardly 6 hours we are in the travel only. So it is not, that means that we are early morning hours we have to start because the wildlife this one is also wildlife animals and all those things are also are observed that now we observe that one, but we should not give any, we are not giving any trouble to that people. They will not come to you. Otherwise always you should be very careful because in the forest area you should be very careful about that one. So we early morning hours we started around 7 o'clock before the just sunrise was started. We started that one by waking. Sorry,
Yeah, presentation. ನನ್ನ ಲ್ಯಾಪ್ಟಾಪ್ ಆನ್ ಮಾಡ್ಬಿಟ್ಟೆ.
is any trouble is there, sir?
ಬ್ಯಾಟ್ರಿ ಯಾಕೋ ಸಖತ್ತು ಬೇರೆ
Hello.
ಮೊಬೈಲ್ ಪ್ರಾಬ್ಲಮ್ ಆಗಿದೆ.
Hello.
Continue, sir. Continue.
Yeah, thanks. If you are having any problem, please let me know because I'm changing the slides. If you are not slides are not changing, please let me inform. So this is the things we observed. So we suggested that we travel to that place and we observed some water bodies and all those things. And again we came back and we did the GPS study inside that tunnel. And we understand that the water bodies are not that much influencing. So we by seeing this one, some water bodies, some like aquifer, aquifers, something, some water, it was in the soil, in between the soil, it is not like the some big canal is running at that location, something like that. So we observed that one, but we suggested that instead of, if you are having a more amount of trouble in this one point of view, better you started from the south portal, better you come from the north portal. Instead of changing the dimension of the tunnel straight line, not 14 kilometers, you start from the other side of the tunnel and come and meet this point. If you then your problem will be solved like that, we suggested. Because some water bodies we observed something like this, aquifers and all those things, and we suggested that if you are instead of taking a risk point of view, you start from the other end of the tunnel, something like that we suggested. So they are, instead of changing the dimensions and all those things, they started from some other side of the tunnel. Now tunnel is also ready and it is running also. Narendra Modi ji opened that one, and it is the tunnel is the vehicular movement is there, and all those things are there. Everything very nice. But whatever the problems we are facing is that because we entered into the winter season, so in the rainy season is also somewhat okay. Winter season means barf, because fog will start. If the fog will start means again we have to come back to our Dehradun region. So the vehicle by our two-wheelers. If you are coming by two-wheelers, by you in the winter season, in the fog is there and all those things, grip will not be there. Vehicular gift Kulu Manali, I think so. Maybe everyone heard about that place. We have to cross the Kulu Manali, that region also, when we are going to that place, that location. So we have to come back as early as possible from that place to the Kulu Manali, because again we have to climb that hill and we have to get down that hill, and again we have to climb another hill. Within a day it has to travel all these things. We have to travel through the Punjab, Chandigarh and all these locations to reach Uttarakhand. So that's what, from Uttarakhand to Punjab, Chandigarh, Himachal Pradesh, 3 states we have to cross to this location point of view. So within a day we have to travel, because it's not that much easy to stay somewhere else, to get the hilly regions, to get the accommodations and all those things everywhere. It is not that much easy. We have to plan it, that one. So that's why we have to travel. The moment when this baraf was started, they suggested that BRO people, as early as possible you should make a move. Otherwise it is not possible. You will be there within 2 to 3 months. You will be here only. It is not, vehicular movement will not be there. We will not allow. We will close the borders, all the borders. We will not allow any vehicular movement point of view, because slides will occur, landslides will occur. Chances are there more amount of landslides and everything you can observe. So that's why they will take the utmost care of the human lives point of view. The border road organization people will take care. So this is the people from the Professor Dr. Bhoop Singh from NRDMS. He was retired right now, and he is the person from the NGA, Norwegian Geotechnical Institute, and he is my colleague in NGF. And these 2 people are from, he is from the some private engineering college, he is from Anna University, geology background. And we all are traveled to the once that work is over, another work was assigned to the by Norwegian people are coming to place by using the GPS. Another assignment is there for us is Ooty. Ooty region they want to because so many slides are occurring at that location. Also recently we submitted a project proposal for the Kerala region point of view because at that time because right now NRDMS was title was changed to the NGP I think so, National Geophysical Program, something like that. He is suggesting. So government of India is having a good amount of money about the landslides point of view. They are very much encouraging for the landslides point of view. If you are having any ideas point of view, NGP, early warning systems or anything, you right now recently some huge amount of rainfall was there in the Vijayawada region. Our and some so much amount of this was happened. Floods was there and all those things. So many problems are also occurred. So that was you maximum the projects are putting in the Himalayan region only. They are very much interested about the Himalayan region. If you are putting Delta X also, if you are adding Delta X, they are ready to pump the money just like that. They are ready to give the money and they are ready to accept the funds projects, and you can get some good equipment also like GPRs, MASW, anything because they are not entertaining the softwares, but equipment's point of view they are ready to sponsor because in the end also I will show one more slide. Recently we were purchased around 70 to 80 lakhs MASW, sorry, biaxial shake table. I can show it to you that from the department side we purchase, not from the division side. Department side, civil department side we purchase under the FIST project. So government of India is ready to fund, put the money like these programs or anything about the education point of view. So think about that direction. So this is the GPS we are using, like antennas. One is the transmitter, another one is the receiver. See, this is the transmitter, another one is the receiver. So see, like this for the Ooty region point of view, there are so many slides are occurring. So we are identified as one stretch only. Instead of the entire thing, entire Ooty, it is not possible to do the studies and all those things where the more amount of slides was occurred. So our main role is that how the soil profile is there below the constructions, whatever the things are there, because some constructions are there already are there. So such type of constructions are there, whether they are safe or not, to check that one, because you should not put a borehole at this location. It's not that much easy to drill a borehole in a hilly terrain and all those things. So that's why this type of NDT techniques we are utilized used that one, because this is all here the location also. The main problem is that to carry the MASW equipment, it is somewhat very heavy. Here there are no antenna, no cables are not, nothing is there. Even this small cables itself, we faced so much amount of trouble, because along with this one our data DAC will be there, data acquisition system. For that one power supply should be there and all those things. So again we have to carry some generator and something like that, we to take care of that one. So much amount of trouble. And see, in the laboratory means everything is the confined, all the things, everything we can arrange that we can get it from the power from somewhere like that. If you are going to the field, it's not that much easy. We have to address such type of problems. We have to take care different types of the problems. See, this is the one location, like step locations, how to separation will be there when you are dragging the antennas along the steps, means some difference is there. So you have to address such type of problems also when you are dragging the antennas. This is the one another location. Another location we tied up with the whatever the vehicles we travel with, that one it's in that vehicle we kept our DAC. With that DAC we connected our cables, and all these cables are connected to the GPI antennas also and all those things. So we have to address it, attached this one to the, initially I was dragged that one, that the antennas, then later I was attached to the band itself. Vehicle is moving very slowly, automatically. Transmitter will generate the waves, receiver will receive the waves, and all the data, everything is connected to the DAC, and it is going to the laptop, and there we are connecting the collecting the data, and we are analyzing the data, how the soil profile is there, and all those things to address that one point of view. So that is the one another look, one thing we are used some of the disaster studies for that point of view. We are addressed that one by using the GPR's point of view. And coming to the some other location, this is the one important school area. Actually, I should not reveal the school name and all those things, but I am saying the things. This is the international school in the Dehradun region, not in Dehradun, Mussoorie. I think so. Very famous Mussoorie. All the IAS, IPS officer, everyone are getting training at this location only. Very cool, very nice area. Because Dehradun is the foothill of the Mussoorie region. If you are traveling to the around 14 to 15 kilometers, that means it will take around 14-15 kilometers. It will take around 1.5 hours to 2 hours, because completely like Tirupati, everyone knows that one. Tirupati, that Ghat road will be there completely. Definitely, you will get chakkar. Chakkar means vomitings. Everything will be there. Definitely, you will get that nice narrow bend and all those things. Roads are not that much. 4-lane road, 6-lane roads, nothing you can expect. Single lane road, that itself they faced so much amount of problem to lane that road, to give the power supplies and all those things. It is the international school, Mussoorie International School. The students are from the different region, different countries. At that time, the school principal is suggesting that, sir, yes, every time we are calling the geology people, they are giving some suggestions to us, and we are doing that things. But now geotechnical people are came into the picture, because that's what. As a earthquake person, I will say that earthquake, everyone, because around 10 or 12 years back, I was joined at NIT Warangal. Once after the Badrinath disaster was happened, my father was told, no, it's not nice time to be there in that region. Why unnecessarily that much amount of distance you are staying? Better you come back in some to the nearby to take care of the parents and all those things like that. He suggested, and I was applied to the NIT Warangal. I got a chance and I was joined here. So when I was joined, so many people are suggested. And so Varangal or Andhra Pradesh, and it is in the seismic zone 2, 3. It is not that much. Uttarakhand, the Himalayan region means it is a seismically prone area. So many earthquakes you can observe very regularly. You can observe those things every day. You can ground shaking and all those things every day, weekly once, or sometimes ground shaking. Everything you can observe. But in the this Varangal region or Andhra region, if those blood places, observing that one is not that much easy. You can't expect that much amount of shaking of the ground and all those things. So he suggested, and when I came here, and the people are suggested, so why you can change your area of research? You be there in ground improvement technique, something like that. Sir, okay, sir, not an issue, sir. I will try my level best, sir. Like that, I suggested. I told. So the things recently, one earthquake was happened very 10 or 15 days back. So ground shaking, I think so. It was observed in the Andhra region also. The people are suggesting more amount of things are there. So immediately, one of my MTech student, he did the liquefaction studies, because even though, because it is my area, because I spend my time to how to grow in that area and all those things point of view. So that time, and the people are suggesting, when the Bhuj earthquake was happened in the year 2001, Vajpayee is prime minister, sir, and he was not celebrated the January 26th celebrations also, because so much amount of loss was there. Infrastructure loss was there, human life is loss is there, so much amount of was there. So he is not in a position to celebrate the Independence Day celebrations. This one, Republic Day celebration, January 26th. So he was not celebrated that one. So he suggests that so much thing is there. So then usually seismic zone point of view, initially 5 zones are there according to IS code, IS 1893. Now only 4 zones are there. Zone 1 was merged into the zone 2. They suggested that no zone is safe from the earthquake's point of view. Like that, they are taken and zone 1 was merged into zone 2. So they conducted so many FDPs. When I am there at IIT Madras itself, my guide was conducting n number of FDPs because NPEEE something like that, some program was there. So IIT Madras was taking that initiation. Professor A. Meher Prasad, Professor Devadas Menon, Professor Dauda Godar, and all these people are involved in that one. Professor B. N. Rao, and all these people are involved in that earthquake studies and all those things point of view. So I was also involved some of the FDPs to take what is the work I was involved and how I was analyzed that studies and all those things. I can show it to you in the coming slides. What my studies and all those things. So what happened is that here our people are suggested their point is that initially everybody are not interested to study about the earthquake. If they want to study the earthquake means some one big earthquake has to come, some so much amount of damage should be there, then immediately people will run behind that one. So much, so no one is safe from this earthquake point of view. Do the earthquake studies, do the earthquake studies, do the earthquake studies. Up to that time, everything is going on. Let it go. Why you should worry about that one like that? So that's why only. So I am not interested about the earthquakes, but my area of interest is earthquake. Some earthquake should happen, some human life should have trouble, some infrastructure should loss. I am not interested about that one. I am not. Very much interested. Some damage should happen like that. But everyone has to do that studies also, earthquake studies also at the time of construction, because when the recently earthquake occurs also, when the media persons came and they are asked, sir, what is your opinion about this one point of view like that. So their point is that first thing is this one, everyone's thing is that it is around 100 kilometers from the source, from Warangal to around 100 kilometers it was happened, that triggered, not at the surface level. Around USGS is saying that around 80 kilometers there, but MGRI people are, Hyderabad people are saying that around 10 kilometers depth itself that triggering was happened, something like that, because different stations are there. USGS means United States Geological Society. They are America people, they gave their data, and the NGRI people, Hyderabad people, they give their data and all those things. So we are doing our studies by taking the different inputs, and we are taking that one, and we are doing our studies and all those things. When they are suggesting that one, we suggested. So no area is free from the earthquake's point of view. When you are going to raise a high-rise structure or any multi-story structures or any single-story structures or whatever it may be, first of all, do the ground response analysis. That is the first sentence my student was suggested. He shared his MTech thesis and he told. He completed in the year 2017. His good name is Nishant, and he's saying that, sir, whatever we suggested, we taken as an input, and we did the ground response analysis for the Andhra region only. I think so, Vijayawada region, one of KLU University. I think so. That guy's student was there. He approached me, sir, and helped me in this location like that. His good name is Madhu. So he asked me about that. So for his helping point of view, I gave my MTech student also. They did the liquefaction studies by taking the whatever the borehole data is available nearby locations. We taken that one. The constructions are happening. Before construction means everyone will do the SPT test, or otherwise any borehole they are drilling, any bore or anything they are drilling, that one means definitely they will take the soil sample, they will do the testing and everything. We are not asking anyone. Whatever the data you are having, provide the data. We will take that data and we will take whatever the right now computer science is a very artificial intelligence is the very famous, very things. Students are parents and students are very interested about that one, that word, catchy word, artificial intelligence, machine learning, artificial neural networks, and all those things. Because nothing but computer science people, faculty are asking me. So if you are having any problem, come to me, because we don't have any problems. Computer science people, If you are having any bearing capacity problems, any settlements problems, any this type of problems, whatever the problems are there, landslide problems, earthquake problems are there, you come with that one. You come with that problem. For on that problem, we will develop our codes. We are going to give some solutions, something like that. So finally, the main source is the civil person only, civil engineering person. The problems are constructions are doing by the civil people only. The ground soil profile, soil testings are doing by civil people only. Everything is there in the civil engineering only. So you are the main thing for the computer science, electrical, and electronics. Everyone will ask. They are seeing towards civil people only. They are asking always, because I'm tie up with so many different types of the divisions, departments, electrical persons, ECE people, computer science people, mechanical people, everyone, metallurgy people, everyone. Recently, not recently, 2 or 3 years back, one of my student is working as doing PhD in Canada. He did on the bio. By injecting bacteria into the soil, how the strength is going to change. Generally, bacteria means every people will afraid. It is going to damage your health point of view and all those things like that. So, but some bacteria are good bacteria. It is going to increase the strength of the material, soil material. So that type of things also will be there. So we are taking that bacteria by with the help of the biotech people. We are injecting that bacteria. We are cultivated that bacteria from 7 days, 7 to 10 days. MIs from Maharashtra, from Maharashtra, we can purchase the bacteria, and we cultivate it by using the different types of the organic material and all those things, cultivated bacteria in the closed atmosphere and all those things. But we injected into the sandy soil only, not in the clay soil. Why? Because the movement of the bacteria is going to get trouble. So that is why we injected that bacteria into the sandy soil. And one of my colleague was tried to inject into the trying that bacteria into the clayey type of soil. But unfortunately, at the same time, the corona was started at that time. So that one girl was initially tried with that using that bacteria and all those things, but suddenly she also gave up. Working in the laboratory and all those things, it is a problem because we completely the institute is closed. The gates and everything are closed. No one should enter into the campus like that. We vacated completely campus at that time. So she also tried with the sand only. Somehow she completed that project. So that's what we injected bacteria into the soil, and how much the strength is going to increase. See, at least 1% is increase. Also for me, it is happy only. It is a waste material instead of the unnecessarily damaging my soil by injecting some GGBS, something like that. So we are now one of my PhD scholars. She is utilizing the geosynthetic material. I think so. Maybe last I can show that material if the time permits for me, because already it is 45 minutes. So I can run the slide somewhat fast only now. She is using the geosynthetic material. She is working. So coming to this problem point of view, the principal was suggested that, sir, this is the international school. You are our mind. First request is that don't discuss with any student, any children, not student, children, very, very small children. They are having the charges are very heavy for the international school. They are charged at that time itself lakhs they are charging, but maybe now it is going to the crores or something, I don't know. So they are charging heavily. So students will be panic condition. Then if you don't discuss anything with the children, you be whatever your observation is there, put it in a paper, submit it as a report, something like that. So what happened is that if you are observing nicely means some settlement was there. It was, you can observe this one in our locations also. See, this is the one swimming pool was there. Swimming pool some around that girl, one girl came. She gave some chocolates to me when we are there at that out on the other side of the swimming pool. It is the other side of the swimming pool, and we are there at the swimming pool. One girl came. I think so, first class or second class. I don't know exactly. She gave a chocolate. So, okay, yeah, very nice. What is the occasion like that? I asked. So today is uncle. Today is my birthday, uncle. Like this, she told. Oh, very nice. Happy birthday! I told. She gave the chocolate. Immediately, she jumped into the swimming pool. Why? Because they prepared the pools like that. Some swimming pools, something very nicely they prepared, and she is swimming very nicely and everything. But the problem is that other side of the pool, water is leaking heavily. You are now you can't observe this one at this location. Heavily, water is leaking because the settlement point of view, all these things are happened. I can show the coming slides. Not this one. I think so. This was yeah, water is leaking heavily. The problem is that one settlement. One side it is ground is down, and side it is up. So that's why so geology people like this. So many cracks are there and all those things. Whenever the cracks are there, some geology people, there's people are suggesting that okay, take some cement, put some paste on top of the one, put some carpet. Every nobody can see that one. You can run that things down 1 or 2 years. No problem will be there like that. But that is not a solution. The problem is there in the roots, in the soil. Something is going down. So you have to address such problem, that problem, first of all. So down after 1 years, maybe it may be heavily, it can be settlement will be there. You don't know what is going to happen. So you have to address such type of problem, first of all. It will maybe suddenly sink heavily, so much amount of settlement will be there. You have to address such type. Ground improvement technique means that one only. By injecting some chemicals or some bacteria or something, other sources, chemical injections are there, going to the putting some piles or something else are there, different types of the things where by using that one, and you have to address such type of problems first of all. Otherwise, by putting some cement paste and putting some carpet, temporarily it is going to address your solution, but it's not the main thing. So you should be very careful. So then coming to the another one, disaster point of view, this is the thing. Another one, another work DST was allotted to us, work was allotted to us when the Badrinath disaster was happened in the year 2013. DST gave a task. They divided all the people, all the scientists into the different groups. Chardham Yatra, I think so. Maybe good number of people have heard about that one. Chardham Yatra, 4 locations are there: Yamunotri, Gangotri, Badrinath, Kedarnath. 4 locations, 4 valleys, different hilly terrains, 4 locations. If you want to travel, miss, it's not possible. Your vehicles will not travel through your vehicle that much. It should be very dangerous. Especially in the rainy season, it is very dangerous. Only in the summer season only you can able to travel. So when the disaster was happened, CM of the Uttarakhand, and that time he came to the NGF and he called all the scientists, and he addressed all the people. And everyone is suggesting, sir, this is the problem: heavy rainfall, so much amount of rainfall. That's why whatever the soil is there, everything is washed out. That's why this many number of boulders are falling. This many number of people are died, and all those things. So many people, so many complaints. Everyone was there. So after he is listening of around 45 minutes, and afterwards he told. And once everyone's discussion is over, he told only one sentence. He addressed the people. See, I am here not to listen the problems. I want only the solution. Give me only solution. I want to think everything should be open within a very soon. This is in the rainy season. Immediately winter season will come. Winter season, anyhow, that everything is closed because of the fog and all those things. Vehicular movement will not be there, so everything will stop. Only the summer season only vehicular movement will be there. All the pilgrims, everyone will travel through that place, and everything will be there. So coming to the summer season, everything should be vehicular movement should be there. Like that, he suggested. So you want asking how much, what type of help is required? You let Uttarakhand government said, we are ready to help, take the permission from the DST and all those things. And he asked the government of India, DST, this much amount of thousands of crores of money is required, so much amount of damages are there, and all those things like that. So then immediately DST was gave a task for us, travel. All the people, all the scientists, they divided into some different groups. So one group went to the Badrinath, one group went to the Yamunotri, we went to the Yamunotri, one group went into the Gangotri, some other people like that. Well, they gave some mobile phones with that GPS. They are involved. Install GPS is there, and Bhuvan software was developed at that time. RSJS people, they developed and that was installed in that one. So what our role is that some students just completed BTech from the Dehradun University, DIT, Dehradun Institute of Technology. They just completed. They are searching for the jobs at that time. We hired that students, and we taken the students to the Uttarakhand region. So, sorry, Yamunotri region. So it is not possible up to some distance only vehicular movement will be there. Then afterwards we have to go by tram, walk only. This one. So what is the problem is that students, like, they are climbing very nicely, but we have to, the only horse riding will be there, otherwise we have to go by walk. And another one is also there, some people will old people are there, means they are carrying by some, this one will, 4 people will carry that one, but some things they will say that one, I don't know exactly the word, I am missing that sentence, that what they are calling that one. So by using that one, they are carrying the old people. So otherwise you have to go by horse. Horse riding means again your back pain and everything will be there, because continue it is 90 degrees will be there. 90 degrees you have to climb. So horse is climbing that one means your backbone, some problem will be there. So you should be very, very careful that place. So what we have to do is that we have to travel around 11 to 12 kilometers by walk. And we have to that 12 kilometers are there means some along the stretch around one location 5-6 houses are there. Again, if you are traveling to 1 kilometers, around 5-6 houses are there, something like that it is there. So we have to take the pictures and all those things, and we have to take the picture and we have to upload that one. It will be appear in the people who are watching, and they are sitting in the Delhi, some central place is there, that center they are searching where I am, they are searching where the troop is there. If you are traveling through the M03 region means where our troop is there and what are the damages, we have to take the picture and we have to upload that photo and we have to give some prescription. So this is the thing was happened. Windows are broken, doors are collapsed, some roads were damaged, and all those things. And I think so. In coming slides, I can show that one. So this is the thing. One thing we are observed. I think so. I was missed that one. See, this is the another one equipment we are having, the cyclotrioxide testing point of view. This is also was supported by the. We are purchased, and I was joined at the NIT Warangal from the institute level. We purchased this one. So this is the thing to find out the dynamic soil properties point of view. Vehicular movement is there. Means static means only you are compressing the soil sample. This is my soil sample, but dynamic point of view means it is compressing and releasing the load. Compressing and releasing the load. So what is happening is that when it is compressing and releasing the load means completely the soil sample is not coming back to the original state. So some permanent settlement and deformation, something you can observe. This type of problems will be there. So you should address that type of things. What are the modulus, how the changes are happening, and all those things you can observe. So in this slide you can observe this one, that one. What is happening like that? See, residual strain in the after the first cycle. Then the second cycle, after second cycle, the residual settlement is more amount of settlement, and all those things are there. These are the things only, because if you are designing a structure with the completely the things means you are going to give the wrong results only to the vendor, the owner, whoever is constructing the constructions and all those things. After that, it is not coming back to the original stage, and it is the permanent settlement is there, but you are not taking the permanent settlement, you are taking the total settlement, means you are over calculations, and you are shooting up your cost of the constructions and all those things. So you should be very, very careful when you are designing the structures by doing this type of the values, and you have to design the things. So this is the things one of our my MTech student did in the year 2014-15. She did the afterwards she joined in the PhD at IIT Hyderabad, and then later she moved to married and she moved some Japan or somewhere she moved Europe countries after the marriage. So she is there. Sorry, these are the damages. I was slides are moved that side this side. These are the damages in the Yamunotri region. When we are traveling, we have to travel by this. The roads are damaged like that. We have to take a picture and we have to upload that one in the Bhuvan portal, and it will we have to share the things. This is the way the pavements and roads and everything was damaged, and we have to address that problems like that. So this, see, but by seeing on the top, very small canal is running like this, like you can observe. But if you are going to that location, water is moving, going very fast in the very cold. Even if you are going to the what is that? But this one is the Rishikesh, Rishikesh region, because all this Badrinath, Badrinath, Yamunotri, and all those things. Starting point is Roorkee, Rishikesh only. It is going to start. Rishikesh place. All the vehicular movement and everything will be there at that location only. So at that time, the water, if you are taking the giving something, everything, Harti and all those things, you are giving the Ganga Harti and everything. So many things they are doing at that location. If you taking the bath and all those things, water is very cold, very cold. So you should be very, very careful. Going very fast and very cold, and you should understand that type of problems and all those things. So these are the things, slides we are observed. Once along the line, the pipelines and everything's are laid, everything. But whatever the soil is there below the pipeline, everything was washed out because of the rainfall and water movement and all those things. Everything was washed out. Everything was washed out. Everything is hanging in the air. See, this is the roads. How the roads are damaged and all those things. This is the vehicle we travel. Luckily, when we are traveling exactly before a vehicle is reaching, that slide was occurred. Then afterwards, they brought some JCB and all those things to clear the roads and all those things at that location also. Because we have to go further. We have to go up to the end point and we have to see that one, what are the damages are there, and we have to give the report to the government of India. Depends upon our report only, government of India will release the funds, and these funds will release. Then again they can take up the results and they can do the problems and all those things. Right now, that's what only we are going. Instead of the we are using the drones also. We are planning to use now the landslides point of view, earthquakes points of view, early warning system point of view. These are the things we are planning with the ECE, electrical people, computer science people, all these things, drones and all those things. See, this is the person, these two people from the students from the DIT, Dehradun Institute of Technology. They are taking their photographs and all those things, what are their observations. They are noting down on the paper, and simultaneously they are putting onto this one also. That this is the vehicle, Tufan vehicles we are calling these things, and these vehicles are moving. In these vehicles only are these vehicles only are moving that much, because the road clearance is not that much, because very heavy boulders are there. If the vehicle will damage heavily, if you are going through your high-end equipment and cars, good cars and all those things, the road clearance is not that much, means it will going to damage your vehicle, everything. So you should be very, very careful. So this is the thing, JCB I am saying. When we are traveling, suddenly the slide was happened, and local people are called the JCB, and they cleared the road and all those things for us. You see, this is the way. The pipeline is completely hanging in the air. No, initially when they are constructed long back, for the supply of the water circulation and all those things, it was laid at that on the soil. But because of the heavy rainfall and all those things, whatever the soil was there, loose material was there, everything was washed out through the water, and it is hanging in the air. So we have to address such type of problems. See, this is the one problem, one of the problem. And this was constructed long back, because the hotels are there, something. If you are observed that one, the DST side, government side, our main interest point is that you don't argue with any public. You just take the photographs and you say that one come out. Don't say that one you are giving the money or nothing. We are not sending you to give the giving the money point of view or any solution point of view, nothing. We want to know that one how much amount of damage was happened, just that one point of view. See, this is the thing, he was constructed on the some building he was constructed, and everything was this much amount of soil was washed out, and the person owner is saying that because of the heavy rainfall, the whatever the soil was there below this column, everything was washed out and it is hanging in the air, something like that he's saying. But we, by observing that one, water is going very depth, not that much nearby, very so much amount of distance was there. So what we, our instruction is that you just take their opinion. So we are taking their opinion and they, we are addressed that problem, informed that one. So this is the slides are happening in the that place, Badrinath region and all those things. This is the slides, whatever the tiles and all those things in the school region, everything was, tiles are damaged, everything. So they are putting again some more tiles, they are putting some school locations, some cement paste and all those things, that one only. They are not addressing the exact problem. So these are the good number of students are there, and we travel these people and with that people and to take that one point of view. What are the problems? This is the thing. When exactly the fog is going to start, same thing. Whatever the problem we faced when we went to the BRO Kulu Manali region, same problem we observed at this location also. Badrinath disaster time also. Winter season, when fog is going to start, so we have to vacate the camp, that place as early as possible. So there is no our maximum. My food is that maximum. I survived with the Maggie. That thing will be available for us. Maggie is readily available. That some households will be there. They will put in this one. There is no stove or no gas stove or anything. Simply there some sticks is this and some fire will be there. In that fire they will put that one and all those things. So once in the Badrinath region, Yamunotri region, we traveled up to the 11 kilometers. In between we are having the Agnikundam. So the people are the main source of the cultivation is there, aloo only for them. So that's what my wife is told. Oh, you went to the nice place now. When you are coming back, you bring that aloo from that place, like that, because there the bag of aloo is only 2 rupees. A bag, that means that around 50 kgs or 60 kgs, only 2 rupees, not kg. I am saying bag of aloo, because they are cultivating that much amount of aloo only maximum. So the people who are staying there, they are bringing some chawal, that means rice, and some aloo. Those things only they are bringing to that place, and they are putting that one at that location. And it is in that much cold place also, so much amount of heat is coming. So they are putting into that one, and aloo will be there, and rice will be there, everything will be there, and they are taking it as a prasadam, and they are eating at that location itself. Very nice, that one. But people are saying, people, scientists, everybody are saying some sulfur, this thing was there, it is traveling through that one, that's why this much amount of heat is coming, something, so many things they are saying. But so many research is going on at that side, still so much amount of things are there. So finally, if we are traveling up to that place, this type of bridge is there. Once you are traveling that bridge, at the top only this Amavar, that means goddess will be there at that location. This goddess will be there up to the winter season only. At the winter season, when the fog is going to start, they are bringing that goddess to the down foothills only, because foothills and all those things they will bring to see this one point, this goddess point of view. People are traveling up to that much amount of distance by horse riding or anything. So this is the our time only. Some marriage was happened, that bride and bridegroom and all those people with the troop are traveling through the by walk only up to that location, and to take the blessings from the goddess and all those things. And when we are after our coming back, we had some other location we traveled, and we observed this one, how the pavement was damaged and all those things point of view. See, some power station is also there. That location, it was completely filled up with the water, and power supply is also completely down. So they are addressing the problems, and I suggested this guy students, but students, they are not able to listen people's voice. I told, because the wildlife sir movements is there, you should be very very careful at this location, something like that. But he's taken some nice photographs and all those things, see, this one of the bridge long back, it was constructed completely because of the water flow, heavy water flow and all those things, completely washed out. This is the equipment we purchased on the DST fist project, biaxial shake table. See, this is the height of the laminar boxes, different boxes we purchased, and all those things, some different cabin and everything. We are keeping that one. In this cabin only, our cyclic axle is there, MASW is also there. Everything we are keeping in this room only. Everything. See, means that we are doing some pilot studies. Like, we are filling up, instead of all this cabin, all these laminar boxes, around 4 or 5 laminar boxes only we are keeping, and we are filling that one with the sand or clay or anything. On top of that one, we are keeping some weight and all those things, and we are shaking that one, instead of uniaxial, two ways we are shaking. That means in this direction and this direction, two directions we are shaking that table, and we are observing that we are giving that real acceleration time histories, where that earthquake was occurred. That one we are measuring that one by using some different sources, NGRI or USGS. They are measuring that one, acceleration time histories, by giving that one as a input to this box, and we are observing that one, how the soil is moving. That much amount of soil was there, how the things are there. Suppose if you are constructed a structure or anything on such type of soil or anything, how the damages you can expect, how much a collapse or settlements you can observe, and all those things. To address such type of problems, how best you can do, by giving some she is the girl, she is using the biaxial shake table. I don't know, this will not work. Video is there, I don't think so. Video is not. I was not given that one. Support. I was not given. And you can observe that one. But two directions it will move, and you can observe those things also. And she is, instead of to address her settlements and all those things point of view, she is using the geosynthetic material, some geoforms or geosynthetic materials to placing in the different layers to address. If suppose she is planning to keep 3 layers, 3 boxes only, means each thickness is 15 centimeters. Is the every 5 centimeters she wants to keep the geosynthetic material, and she is giving at the bottom of the table the acceleration to time history, and it is waves are traveling through the soil, and it is reaching to the surface level, how much it is going to reduce or how much it is going to amplify. She is going to observe that one. By this much amount of acceleration is coming, by taking this value only, you have to design your structure. Main thing, your structure or pavement or whatever it may be, you have to design, depends upon that one only. Don't design the just like that. Whatever the IS code was given, I will design on that one only, means it is not designed. IS code was not consider the what is the exact soil is there below your structure. Your soil profile is there at that location, so it is generalized one. So before you are going to do that business, you have to take this one. That's what my MTech student told. Sir, when we have studied the liquefaction studies, and by taking the different accelerations, time histories, and all those things, previous data and all those things, we considered the 5.5 magnitude earthquake as an input, and we did the liquefaction studies. Sir. Whatever the recently earthquake was occurred in the Andhra region, we observed around 5.4, sir. So it is almost near to our results, sir. So our results, whatever we gave the results are some validations are like that is suggested. Definitely, when the people are initially, they will think that it is a low seismic region, if our results are not valid, we will go with our old ways only, like that they will suggest, they will think. But once you are constructing a structures or whatever it may be, You have to consider this type of things. You can reduce the human laws and the human infrastructure laws and all those things. You should be considered those things at the time of the things. So it's already 3:15. If you are having any queries, I am ready to address the questions. Because I am moving to some other thing. If you are, I think so. Maybe some disaster, like, because all are related to that disaster side only. What are the damages I was observed, and recently even in our Warangal region also near Bhadrachalam, they are constructing a dam, and that chief engineer was invited us, and we went there. Water resource people, geotech people, structures people, everyone was went there, and he gave a problem. So much amount of you are suggesting that instead of in terms of the earthquake, I am saying that one, that waves and everything in terms of the water waves, they are also giving some things, sir. So how best I can take those things like that? He's asking me. His problem is that one, some heavy rainfall was there. Because of that rainfall, whatever the power station is there, completely one day it is shut down. So that is the main problem. So he is asking, so this type of problems I should not expect that one day completely power shutdown means that nearby people is very horrible to survive nowadays. So that's why his chief engineer main objective is that one, to address the problem point of view in the near Bhadrachalam region. He invited us to take a task and all those things. But okay, still it is going on, discussions are going on and all those things. Okay, if you are having any queries so far, any in these presentations, I'm ready to answer. I will try my level best. Please.
Now I am requesting HOD of Civil Department, Dr. K. Sundar Kumar sir. Please give the concluding remarks.
హలో
Hello.
గుడ్ ఈవినింగ్ సార్, డాక్టర్ కళ్యాణ్ కుమార్ గారు.
Good evening, sir.
సార్, ఐఎమ్ డాక్టర్ కే సుందర్ కుమార్ సార్, కోఆర్డినేటర్ ఆఫ్ దిస్ Atal FDP program. And thank you very much, sir, first of all, for accepting our invitation and joining with a wonderful session regarding ground related issues. And this GPR, you have very nicely explained with visuals, and definitely it is enlightening us in the direction of this disaster related issues. And personally, I have benefited by your lecture, sir, by looking at all the information and listening to your lecture.
Sure, sir. Sure, sir.
Yeah. So this GPR technology, it means what kind of wave, sir, through transmitter and through receiver and all? Is it sound waves, sir?
Electromagnetic waves, sir.
Electromagnetic waves. Okay.
Yeah.
So they penetrate to soil and they recognize the features.
Yeah, yes, sir. Yes, sir.
Okay, sir. So, but this is in situ program, sir. This GPR system and all. Can't we do? Can't we take the help of satellite imagery, sir? Like microwave and other nowadays, the different types of satellite images are coming into picture, which can penetrate to cloud, which can penetrate through vegetation, even which can penetrate to ground also. Can we make use of this advanced microwave imagery, sir, for this kind of exploration?
Sure, sir. Thank you, sir. See, the thing is that actually, when this GPR, MASW, these things are came, still as a civil geotech person, still so much amount of debate is going on, sir. because we are not actually the geotechnical person. Maximum we are depending upon the SPT. Whatever the borehole we are driving, we are drilling that one, and we are collecting the soil samples, and we are bringing to the laboratory, and we are doing the testing and all those things. Finally we are giving the results. So much amount of debate here. NDT point of view, we are not giving any damage to the soil or any structure or anything. So the people are not accepting the results that much easily. So you are going beyond that one. They are taking the, instead of the NDT, at least it is touching the ground. Our GPR or anything, it is touching the ground. But if you
Okay.
are going to the above the in the air, you are taking the from the sky, you are taking the photographs. So how much is people are accepting your results is a very how much amount of deviation will be there. Everything once one unless until we are validating the results, whatever the ground truth is there, and you are validating your photographs is the biggest task, sir.
Okay, sir. Okay, sir.
That is the main thing.
Yes, sir. What are the various interferences, sir, for this GPR works? Because there may be water bodies, there may be some rock formations, there may be some other different heterogeneous material will be there below the ground. So, don't you face any issues regarding the transmission and receiving, sir?
According to Codal point of view, already they mentioned, sir. Already, whatever the publications are available and everything, we are having that one. Any HRP classification was there. If the shear wave velocity is varying from this interval to this interval, this is the type of the soil, like that. It was given already. According to Codal provisions point of view, we can take that one also into the picture as a benchmark, like that.
Okay, sir. Thank you very much, sir. Thank you very much, sir.
Thank
And
you, sir.
I request the participants to ask any questions related to your queries. Participants, any questions?
Dr. Kalyan, good afternoon.
Sir, good afternoon, sir.
One question, sir. Uh, with reference to geotechnical engineering, what kind of studies you can make? Please clarify once again using your shake table. 2D shake table you have procured in 22, I think.
Yes, sir.
What kind of studies you can make, please?
We can perform the liquefaction studies, and to determine the this one, the what dynamic soil properties. We can check that one. How is the soil? Not only soil profile. How best if the waves are traveling through the soil, how better it is going to give the response to the structures point of view, and all those things. We can do the different type of studies. We can perform, sir.
Infection also is possible, sir?
Yeah, yes, sir. Yes, sir.
Okay. Thank you.
Thank you, sir.
Any other questions from any participant? So, if no other questions are there, let us move on to vote of thanks by Professor Sombabu, sir. Sombabu, sir, over to you.
So thank you so much, sir. Sir, Dr. Kiran Kumar, sir, on behalf of everyone, I would like to express our heartfelt gratitude for your insightful and engaging session today. Your expertise and knowledge uh, in the regarding to disaster management were truly inspiring, and we are appreciate your valuable perspectives you shared with us. Once again, thank you for your contribution to making this program a success. We look forward to more opportunities to learn from you in the future. Thank you so much, sir.
Thank you, sir. If anything, if you are planning to use the Baxial or cyclotrazole, anything, you please drop a mail. I will try my level best to utilize our laboratory facilities also, sir. Thank you, sir.
Sure, sir. Thank you so much, sir.
I am signing out, sir.
You can sign up, sir. Thank you very much, sir. We'll meet you in some other
Thank you, sir.
session, sir. Thank you.
All the participants, please stay here within 5 minutes. Dr. Fanindra, sir, join now.
Good afternoon, everybody. Dr. Fani sir is joining in a few minutes. Please bear with us. చాలా పెద్దగా Good afternoon, sir. Dr. Pani
Good
Pani sir.
afternoon. Good afternoon, sir. Yeah.
Sir,
Hi.
let us start the session, sir.
Sure.
I'm handing over to Mr. Sombabu, the coordinator of the program, to introduce the today's speaker. Go ahead, Sombabu, sir.
Thank you, sir. Dear participants, thank you for your active participation in session 11. We hope you found it insightful and valuable. Now, as we move forward, we are excited to begin session 12. Please join me in welcoming our esteemed speaker, Dr. KVBN Fanendra, sir. It gives me immense pleasure to introduce our esteemed resource person, Dr. KVBN Fanendra, whose exponential academic and professional achievements make them a highly respected figure in their field. Dr. KVBN Fanendra had received a PhD from New Mexico State University, Las Cruces, USA in 2010. Received PhD in Water Resources Engineering, over 15 years of experience in academia. Dr. KVBN Farendra presently working as a professor in IIT Hyderabad. Sir published 35 journal articles and 2 technical reports and contributed in 5 chapters in textbooks. Dr. KVBN Farendra sir has also contributed significantly to industry through the consultancy works worth approximately 3.5 crores, underscoring the practical impact of his expertise. He successfully guided 4 PhD students with 6 ongoing, and has mentored 10 MTech students, showcasing his immense dedication to research and academic excellence. Farendra sir actively participated in 20 national and 36 international conferences and organized 11 faculty development programs and 5 workshops to enhance the knowledge and skills of academia and industry professionals, and played a pivotal role. Dr. Fanindra sir delivered 30 plus expert lectures in prestigious forums, sharing valuable insights. SAR has Best ITRA Water Project awarded to GRID Sense team in 2014 at IISc Bangalore with cash prize 20 lakhs. In 2022, member groundwater resource estimation committee nominated by Ministry of Jal Shakti. Sir, we are truly privileged to have such a great personality with us today. Please join me in welcoming Professor Dr. KVBN Fanendra to share the knowledge and expertise with us. Sir, the platform is yours. Please start the session, sir.
Thank you very much, Sombabu Garu, and thank you very much for the organizers from Ramchandra College of Engineering to facilitate my lecture at the 6-day faculty development program. Before I start my presentation, can I just get some glance of the participants, means how many have registered and what is their background? If
Sir, totally 220 members have participated, sir, from the different states, and all are associate and assistant and professors.
Okay, sure. Thanks. So my topic is actually droughts, mainly focus on the analysis, propagation and mitigation, a multivariate perspective. So myself, I'm Fanindra, faculty in Civil Engineering Department at IIT Hyderabad. And here is my presentation. First, we will give a brief of actually the one of the natural disasters being the droughts and some statistics about it, and then we will go with the definition of the drought and its characteristics, and then how to analyze the drought, and two works actually, two of my master students who worked on actually. I will discuss in detail about those two case studies. One is on multivariate drought indices, and another is integrated water deficit index. So you might have gone through in these last 5 days, today being the sixth day, about various natural disasters like floods, cyclones, or these kind of if you observe actually the natural disasters, if you see, they are associated with some extreme values. For example, floods deal with extreme precipitations, like actually cyclones, so extreme lower precipitation distribution, so pressure distribution, or tornadoes. You call any natural disaster, okay, you are mostly interested in actually the extreme tiles, either you are an extreme lower tile or extreme higher tile. Droughts are also similar nature, where you are dealing with the lower tile of the distribution. That means the extreme low values of a particular data is of our interest. Extreme low or extreme high is actually the ones that are leading to the disasters. So drought by definition is a prolonged period, unlike most of the other disasters, which are actually the short duration, high intensive ones actually. Drought is kind of a thing where it relates to the prolonged period of abnormally low rainfall, consistent low rainfall, which eventually is resulting in water deficit scenarios. For example, I have the shortfall of the rainfall for few days, you cannot call it as a drought. But if I have a shortfall of the rain for a longer period, which eventually is resulting in the shortage of the water supplies, shortage of the agricultural water, domestic water, or other activities, that you can claim as a drought. So drought by definition is a prolonged period of consistent low rainfall. It's a natural disaster, but has a significant environmental, economic, and social impacts. So it can have an effect on the ecosystem functioning. It can have an effect on the finance aspects of disruption, or actually low crop productivity or low water availability. It can also have effect on the social impacts, like actually displacement of the people or the migration of the people and so on. So this is one of such a natural disaster which can have a direct but intense effect on all the components like environmental, economic, and social components. It mainly results in the imbalance between water supply and the demand. So if the supply is so short and the demand is very high, that imbalance, prolonged, consistent imbalance will result in the formation of the droughts. Droughts generally account for 15% of the overall natural hazards among all, which is significant, and responsible for about 3% of the death toll. So death toll is not significant, but still their damage in terms of the economics or environmental is very high. So globally, droughts affects 5 million people annually and may displace 700 million people by the year 2030. This is the prediction. If you see the top map, it can give the GRACE derived drought severity index, because GRACE takes the data at a monthly scale, how for each month, 2002, 3, and so on, how the conditions are actually the changing. For example, red represents the exceptionally drought condition, how this drought is actually, how the drought propagation or actually drought occupation is increasing over a period of time. We can sense it. Hope I'm audible and the slides are visible, right? Just want to double check.
Yes, sir.
Thank you. So India also has a long history of affected by the droughts in terms of the agriculture, because agricultural productivity and crop production are significantly affected, economy and the population, mainly displacement and other things have been. For example, the Great Famine of 1876, pre-independence, and Bihar famine, droughts, recent droughts actually pretty much throughout the country in 1516 are a few examples. These droughts have led to advancement in various irrigation systems to be improved, or the reforms or water management practices, because how best you can sustain or you can actually recoup or actually you can accommodate that one is more crucial. For example, this actually the drought prone areas significantly, you can see the drought prone areas in a way are indirectly linked to the rain shadow regions. For example, you will have actually much lower rainfall in this region, right? And also here, both geological and rainfall regions and the parts of the central and eastern region. So these are significant parts. If you can see, the regions can best correlate with low annual rainfalls or high annual temperatures. So the low annual rainfall or high temperatures are significant, could be the reasons for this one. So droughts can impact the ecosystem by affecting the biodiversity and all. In particular, water scarcity, degradation of the habitats, biodiversity loss, increased food fares, alteration of the migration patterns, carbon sequestration, soil degradation. These are all a few cases where, in other words, drought can influence, though it's a short of the water for a longer period, it can influence the freshwater ecosystem, the flora fauna, the soil ecosystem, the vegetation ecosystem, and so on. So if you broadly classify the effects of these droughts, the environmental impacts could be, it can alter the ecosystems, it can damage and diminish the food, fuel, and freshwater availability. If you talk about the economical impacts of the droughts, it can exacerbate the food shortages and food insecurity, unemployment, poverty, and conflicts, internal displacement, migration. These are all the economic effects. Health effects can also increase the gaps in the sanitation and hygiene coverage and reliability. And cultural and social impacts can have an impact mainly in terms of the gender or religion. These kind of things could increase. Now coming to the technical aspects, drought by definition is actually the shortage of water, or actually you can say the prolonged deficit of rainfall or water deficit. Can we have four forms? Of course, three are the significant forms. One is meteorological droughts. Meteorological drought is a case where there is a deficiency in the precipitation or increased evapotranspiration. For example, meteorological drought is concerned more about actually the meteorological aspects, like actually the rainfall shortage or increased temperature. Increased temperature eventually results in the increased evapotranspiration. So shortage of the rainfall or increase of the evapotranspiration is actually the first form of the drought, which is called meteorological droughts. And another form of drought is agricultural drought. Agricultural drought mainly talks about the deficiency in the soil moisture or soil water and the plant disease and reduced biomass and all. So there is a shortage of the soil moisture, which is helpful for the growth of the plant or the reduction in the crop yield. That is called agricultural drought. Hydrological drought mainly deals with the reduction in the stream flows, particularly in the reservoirs and the wetlands and the groundwater levels. So if you observe, of course, there is also another called socio-economic drought, where you mainly deal with the imbalance between the supply and demand. But technically, these three are the main drought forms. If you observe, meteorological drought is a kind of a precursor. It is the starting point. there is a shortage. For example, there is a significant shortage of the rainfall in this region. Over a period of time, it results in the lowering of the groundwater levels, or actually reduced water levels in the streams or the rivers, which is resulting in the hydrological drought, because of which there is a reduction in the soil moisture, because of which there is a reduction in the crop yield. So meteorological drought is actually the precursor. That is why you have an arrow here. So so it will transforms to agricultural drought or hydrological drought. So drought propagation is something where it will tells you how meteorological drought is propagating to agricultural drought, or how meteorological drought is propagating hydrological drought. Sometimes meteorological drought follows agricultural, follows hydrological, or sometimes meteorological follows hydrological, follows agriculture. So eventually meteorological is actually the precursor or the starting points. So the propagation will help you to know how this is actually moving from one form to another. And then obviously the question is how I can measure the drought, or how I can monitor the droughts. For that, there are a number of indices. For example, World Meteorological Organization (WHO) has recognized more than 50 indices for defining the drought. For example, there are Palmer Drought Severity Index and Standard Precipitation Index. These two are mainly the meteorological drought indices. Vegetation Condition Index is predominantly the agricultural drought index. Standard Precipitation Evaporation Index is predominantly the meteorological drought. So for defining each drought, you have a number of indices, like your spectral indices like NDVA and all are there. You have very number of drought indices, like example SRI, Stream Flow Runoff Index, SSIMI, Soil Moisture Index, and you have a number of indices. How these indices will define? They will take any one parameter. For example, SPI, Standard Precipitation Index, will take the precipitation. Vegetation Condition Index will take the vegetation condition. SPEA takes both P and E, means precipitation and evaporation. So for example, each index will take one variable and they will fit a distribution to that data, and then they will transform it to a normal distribution, and that based on the normal distribution they will tell the for example, give me a minute. So a normal distribution looks like this, right? So this is actually the mean of the distribution. This is actually the lower tile. Can you see what I'm plotting on the screen?
Yes, sir. Yes.
Good. Thank you. So what you are doing, whatever may be the variable, whether it is precipitation or runoff or soil moisture or vegetation condition or ET, you first plot the distribution of the data and then convert into standard normal. So if the standard normal is like this, actually, of course, standard normal will have a mu equals to 0 and sigma equals to 1. This is the mean of the data. And this component will represent the drought component, because we are interested in only the lower tiles, right? This corresponds to the higher values of that value. This values corresponds to the mean of the data, right? So we are interested only in this value, mainly because we are dealing with the droughts, lower tile dependence values. So any index, PDSA or SPI or VCI, you take the data of that particular region over a longer period, fit a distribution, and then transform that distribution to a standard normal, and then you take the data corresponding to this lower tile. That is what you will obtain the index to characterize. So for example, this is actually 0. Here it will be -1. Here it will be -2 or -3, because it goes from -3 to +3 being a standard normal. Here it will be 1, here it will be 2, and so on. So anything less than -0.5 or -1, okay, you can call it as a drought condition, right? These are all wet conditions. These are all wet conditions because they're all indices are positive. This is a neutral condition. This is a neutral condition, and this is a dry condition. So you get the data, fit a distribution, convert into standard normal, get the equation like this, and the data corresponds to this portion, the left portion, you call it as actually a drought index. That is how actually you define the drought index. So what are the specific or critical objectives generally? Understand spatio-temporal variability of droughts across a basin. Take for any river basin, a river basin of say Krishna, and how this drought is propagating in space domain from one place to another, and time domain, even at one single location, time, place, how it is changing with the time is the first objective we are dealing with. Then develop a cupola-based integrated indices. Then whatever the indices that we have discussed, all these things, they are all called univariate indices. Univariate indices means I'm using only one variable. For example, SPI uses only precipitation. VCI uses only vegetation condition. But over a period of time, it was observed that it is not one single variable which is actually sufficient enough to measure a drought. For example, if I want to define hydrological drought not only results because of the decreased water levels in the streams, but also lowering of the water levels in the groundwater. So I need to have two variables, one to talk about the groundwater table and one to talk about the stream levels, and then combine to actually define the hydrological drought. For example, meteorological drought. Meteorological drought may not be corresponds to only decreased rainfall, but also increased evapotranspiration also. That means it is not the only decreased rainfall that can result in the meteorological drought, or it is not the only increased evapotranspiration that results in the meteorological drought, but it is a combination. So I need multiple variables to define the drought. So the second objective is how we can use cupola-based integrated drought indices to characterize various droughts, because univariate indices or indices based on a single variable are not enough, are not reasonably capture the drought. How can I combine all the variables that are resulting in that particular drought into one specific index is actually we will discuss. Then identify the drought events based on the characteristics, means how to identify those events, like actually, and then what is the investigate the role of various hydrometeorological variables on this indices droughts, means how various variables are actually influencing this one. This is a very, very important figure where we will define, for example, this is what some standardized index. As I told, because you are bringing the standardized index in a normal form, like this, the maximum lowest value it can take is -3, the highest value it can take is +3, and the central value is 0. Right? That is why it is ranging from -3 to +3. Okay. So this value, the values close to -1 actually are water deficit conditions. The values close to plus values are water surplus conditions. So if you got the data, say for example, I have the precipitation data of the monthly scale at this region. What I do first, I will fit a distribution to that particular data, the best fit distribution for my precipitation, monthly precipitation, and then convert that into standard normal. That standard normal is looking like this. If you see the standard normal for different months, I have the data, for example, of 66 5 years of data. So what it is giving, I can say that I have negative values for a few months, followed by some positive values here, followed by some negative values here, positive values, and so on. What does it mean? This corresponds to a drought. This corresponds to wet period. This corresponds to a drought. This corresponds to a wet period, and this corresponds to a drought. Now, how I can define the drought events? Drought events are mainly decided or discussed based on three factors. One is severity, another is duration, another is intensity. Of course, you can actually know that in severity is actually the accumulated values of all negative values of SPA severity. That means what? So severity here is what? Say suppose -1, here it is -2.5, here it is -3, -2.6, -3, -1.5. So if you add all those things, that will become the severity of this particular drought. For example, for this, the severity of this particular drought is, so this is like -0.5 plus -1, another -1, this is suppose -1.5. If you add all these negative values, you will get the drought severity. Then what is duration of the drought? This is the duration of the drought. Duration of the drought will be 1, 2, 3, 4 months. This is another duration of the next drought. Then what is the intensity? Intensity is actually the peak value. So this severity divided by the duration will give the peak value, average value. So based on these factors, you define the drought. Similarly, speed of the drought. At what rate the drought is propagating? You have actually two phases for the drought. One is called development phase and another is called recovery phase. So this is called development phase and this is called recovery phase. Similarly, this is called development phase and this is called recovery phase. Similarly, this is called development phase. This is called recovery phase. If you see here, this is called DDD, drought development duration. This is called DRD, drought recovery duration. So these are all you can call them as, these are the characteristics of the drought, means the parameters by which you can define the drought. If I say that the severity of my drought is so and so, that means accumulated values of all these negatives values is my severity. The horizontal one is actually the drought duration and its ratio is the drought intensity. This phase is called development period and this phase is called recovery phase. Sometimes development could be very fast, recovery could be very slow. Sometimes development could be very slow, recovery could be very fast. It all depends on how your basin is, whether your basin is quickly recovering from the drought or slowly recovering from the drought and so on. Next, as I told, univariate indices are not sufficient or not enough to define a drought, mainly because any drought is not because of one single variable. So for example, any drought, the meteorological drought is not only because of the precipitation shortage, but also because of the ET excess. So that is why there is a theory called Coppola theory. Coppola theory is a theory which takes the two distributions or the distributions of two marginal distributions of two variables, here precipitation and ET, and then combine it to get the Coppola function. So this is called Coppola. This is the marginal distribution of the first one, say suppose precipitation. This is the marginal distribution of the second variable, say temperature. Then you combine this to get actually the distribution or the joint distribution of this one. This is called Coppola. So Coppola is actually, if you see the definition, it's a two-dimensional Coppola is a real function C of x comma y defined on I square with 0 to 1 times 0 to 1, because 0 to 1 corresponds to the first variable, because these are all standard normals, times 0 to 1. So obviously it results in the range of 0 to 1, such that on one end you will have the u, which is first distribution, on the other end you will have the v value. Okay, so Coppola function is nothing but the joint distributions of two individual marginal distributions. Why Coppola function is required? Because one single distribution is not sufficient enough to define the drought, because it's a multivariate analysis. You cannot analyze with one single variable. So generally two significant variables you generally combine to get the drought representation. So Sklar theorem says that the joint distribution, if f of xy is a joint distribution means what? It's a copula function with marginals of f of x and f2 of x. That means f1 of x and f2 of x are the individual distributions. Then the copula will take care. So that means you have multiple ways of defining the copula. One is actually the Gaussian copula. If you see here, copula is taking care of the two distributions. It's a two-dimensional function. The one distribution is standard normal, so minus 3 to plus 3 or minus 2 to plus 2, because standard normals, the variance ranges from minus 2 to plus 2. And this is another variable, standard normal. Gaussian copula looks like this, a T copula looks like this, Frank copula looks like this, and Joe copula, Gumbel's copula, and so on. So essentially what you are doing, the two-dimensional, see, this is one distribution, this is another distribution. You apply the copula to get a resultant distribution like this. This is what the copula function is. So copulas are very, very, very important in multivariate analysis because a single variable is not sufficient enough. So you take the distribution of the first variable, precipitation, you take the distributions of the another variable, which is temperature, and then you combine, maybe a Gaussian combine or T copula or Frank copula and all, to get another distribution which is containing the information of the two. So for this, I will just take 1 minute break. If you have any questions, you are good to ask. Any questions? So are you able to follow?
Sir, yes, sir.
So now, thank you. So now actually, I discussed two of the case studies, one done by my master student, one done by my PhD students, where we took the case of Krishna River Basin. So Krishna River Basin is actually the east flowing river. You are all familiar. So one second. This is the Krishna River Basin, and the enlarged view of the Krishna River Basin looks like this. It's an east flowing river, and okay, you have the Eastern Ghats, and actually this is actually the mouth of the river, and the basin was actually further divided into 7 sub-basins. Upper Bhima here, and Upper Krishna here, and Upper Tungabhadra here. Similarly, Lower Tungabhadra here, and this is Middle Krishna, and this is Lower Bhima Basin, and this is Lower Krishna. So the entire river basin is divided into 7 sub-basins, and it's flowing almost like 1400 kilometers. Western Ghats, the peculiar characteristics of this one is the Western Ghats, which are located here, they contribute only 10% of the area, but there is a very high rainfall, high amount of rainfall. The basin is composed of these 7 basins, and the reason for choosing this one is actually because Krishna is kind of a water deficit basin, unlike Godavari, which is water surplus. So for that reason, actually analysis of the droughts is more meaningful, and you will get very appropriate for Krishna River Basin. And the transboundary nature has resulted in various disputes. For example, if you see this area, actually, the basin is cutting through multiple states, Maharashtra, Karnataka, Tamil Nadu, and AP. So this transboundary nature has resulted in too many disputes in terms of the water management, allocation, and so on. And there is a huge competition, and flows are also minimal. For this reason, we have considered this basin. And droughts are very frequently occurring in the Krishna River Basin, mainly because of the dependence of the rainfall for agriculture mainly. The first study what we have done is actually multivariate drought indices to analyze spatio-temporal drought propagations in the semi-river basin, which is Krishna River Basin. So what is the objective of this work? we want to understand the spatiotemporal variability of the meteorological drought using SPEI. SPEI is actually the SPEI is something which is a kind of a cupola function only, because it uses precipitation and evapotranspiration for meteorological droughts. Then what we have done, we have developed cupola based indices for hydrological drought and also agricultural drought, because agricultural drought and hydrological drought in the Krishna basin are to be defined using multiple variables. Because multiple variables are contributing to this one, we decided to develop two cupola functions and investigate the event-based propagation for each event, how it is propagating, and what is the role of climate, catchment, and storage factors. This is what we have done. So we have taken precipitation data, soil moisture data, NDVA, which is normalized difference vegetation index, potential evapotranspiration data, and also we take the groundwater levels data and stream flows. So precipitation and PET are used to define that, are used to estimate SPEI, standard precipitation evaporation index, because SPEI uses P values and EA values and then marginally combined to get that one. Then for hydrological one, if you see here, precipitation and evaporation are combined to get the meteorological droughts. Now we combine runoff and groundwater levels to define hydrological drought, because a decreased runoff is not only causing hydrological drought, or increased groundwater levels is not only causing the hydrological drought, but it is the combination of these two is causing the hydrological drought. So we combine them to get the hydrological drought cupola functions. Soil moisture and NDVI are combined to get the agricultural drought index, because a reduction in the soil moisture is not only resulting in the agricultural drought or a reduction in the NDVA, but a combination. For example, let me give you an example. If you have a low runoff, you cannot call it as a hydrological drought condition, because hydrologically you can maintain from the shallow water levels. When you have both low runoff and also high groundwater levels, then only it results in the hydrological drought. For example, agricultural drought also, if you have low soil moisture, that means, for example, during the harvest period, you will have low soil moisture. That doesn't mean that it's an agricultural drought region time period. You have to look from NDVA viewpoint, because NDVA will be lower because the vegetation index is much lower there. So it is not one single variable, it is a combination of these two is resulting in the drought. So essentially what we have done, we developed the cupola function of the two variables. These two variables to get the meteorological drought, these two variables to get the hydrological drought, these two variables to get the agricultural drought. Then we have actually analyzed these droughts at different time scales. If you see here, this is SPA 1, 3, 6, and 12. That means for considering monthly, seasonally, which is 3 months, biannually, which is 6 months, and annually, which is 12 months, how these droughts are being changing. Then we define the events. If you see this is based on the run theory, how we are defining the events. Then we understood the correlation, how each one is correlated to other, and how meteorological drought is propagating to the agricultural drought, and how meteorological drought is propagating to the hydrological drought. This is what we have done for Krishna River Basin. Then we only present a few results. I already shared the material with Sombhabu Garu, so you can go through this detailed reports that what we have done for this one. What we have done, we done run theory considering SPA 12, means 12-month accumulation of SPA to identify the drought events. If you see here, these are the drought events. The very interesting figure here is actually where this is one drought event. That is why it is actually shaded as pink. This is not drought. This is not drought. Though you have a negative value of SPA, we are not calling a drought because it's not of sufficient duration. So we defined a drought. We defined a drought by keeping a thresholds. Intensity should be less than -1. Duration should be greater than 6 months, and severity should be less than -4.5. Then only we can call it as a drought. Those events which are satisfying this condition are only classified as droughts. So Upper Bhima has experienced 3 droughts for the period 2002 to 18. Upper Krishna has experienced, see, this is all the drought, because even though you have some surplus periods in this period, but this portion is meeting all the 3 conditions of intensity less than -1, duration greater than 6, and severity less than -1. So Upper Krishna has 3 dots, but this is not meeting, mainly in the duration, I guess. This Lower Bhima has 4 dots, Middle Krishna has 4 dots, Upper Tungabhadra has 2 dots, Lower Tungabhadra has 4 dots, and Lower Krishna has 5 dots. So what you understand from this figure quickly? Upper basins have lower number of dots, lower basins have experienced higher number of dots. Point number 1. But if you see here, the peaks for the upper basins are lower. For example, this is the peak, this is the peak, this is the peak. For lowers, if you see here, this is the peak, this is the peak. Same with every case actually. So lowers, you have a higher. That means upper basins are having lesser number, larger duration. Duration is also large. If you see this, large duration is large here, large here, large here. Duration. So what we observed, interesting observation is all upper basins are behaving in one manner, whereas all lower basins are behaving in another manner. So upper basins have less number of larger duration but low intensity droughts, whereas lower basins have higher number of droughts with higher intensity but short duration. Upper basins have recorded less number of droughts with prolonged durations and high severity. So that is a main interesting observation we have observed. This is how we have combined for each basin. This is actually the PDFs, probability density functions of the first variable and the second variable, and then we combine this to get the copula functions. So this is actually the see, if you see, this is fitted and experimental. So what you do, you get the data and then you fit some distribution, and that for that marginal distribution of first variable and second variable, you apply the copula function to get the marginal or the coupled distribution. Then we also observed that how meteorological drought is propagating into hydrological drought. For this, what we did, we correlated SPEI with IHDA. IHDA is actually called Integrated Hydrological Drought Index, what we have developed by combining the runoff based distribution and groundwater level based distribution. So when you correlate these two, then it will tell you what is the propagation time. So the calculated correlations were 0.2 to 0.5. We observed not so very good, but decent correlation coefficients. So if you see here, for each event, actually, for example, if you observe upper basin, this is actually the best propagation. This is the best propagation. This is SPEA 1. That means 1 month propagation. For example, lower basin, if you observe, this has a 6 months propagation. So the lower basins, you have actually 12 months propagation, because this is SPA 12. So what we observed actually, upper basins, the drought is propagating from meteorological to hydrological very fast within a month. That means what? If you experience meteorological drought in the upper basins, within a month, it will reflect as a hydrological drought. Whereas for lower basins, the drought propagation is, say for example here, the drought propagation is almost 12 months for lower Bhima for event 2. Of course, a few could be exceptional. So what this means actually, out of the total 8 drought events in the upper basins, 3 have experienced short duration and 2 have experienced long duration. So what? Similarly, agricultural droughts. Okay, in comparison to hydrological drought, agricultural drought is more evident with a high correlation. We obtain much better correlation with agricultural drought. That means meteorological drought to agricultural drought propagation is much more mm, clear and effective. So if you see here, Upper Bhima and all, Upper Bhima, you have actually the shorter duration. If you see for Upper Krishna also SPA1, Upper Tungabhadra also you have SPA1. What does it mean? The transfer of meteorological drought into agricultural drought is about 1 month for the upper basins. For example, for the lower, you have reasonably longer durations. That means lower basins have resulted in a delayed propagation of the agricultural droughts. Then we observed what could be the influencing factors. What are the factors which are controlling these propagation from meteorological to hydrological? And because converting from meteorological to hydrological or meteorological to agriculture is mainly catchment activity. It all depends how your catchment is responding. So what we observed, we considered a number of variables like actually the change in precipitation, change in temperature, change in forest cover, change in grassland, change in bare land, change in croplands, change in water bodies, change in storage structures, surface storage structures. To what extent these can influence this one? And then we observed actually that IHDA, if you observe actually, you have a good correlation with temperature. That means actually converting from this is for upper basins. Upper basins actually the change in the temperature has a direct positive effect. Similarly, for this one, precipitation has an effect here, and also cropland has an effect into the agricultural drought. So precipitation and cropland changes are significant contributors to the drought propagation for agriculture, whereas temperature is a significant contributor for the hydrological drought scenario. So this is what we have done for first case study. And just a minute. Any questions so far? Okay. The next one is actually what we have done. We developed an integrated water deficit index. Okay. To take care of this multifacet index, mainly to same thing, but rather than actually we use actually developing two integrated indices, actually integrated hydrological or integrated agricultural drought index. What we have done actually, we developed one integrated index that characterizes the complete storage factors. For example, this figure helps you. From the previous case, we understood actually that this will result in meteorological drought results in agricultural or hydrological. So you have a climate deficit, but you have actually the surplus water. Then it may result in the onset of the drought. That means what? I have one river basin where my climate water deficit means my precipitation is very low or ET is very high. Meteorological drought is there. But I have a surplus of water. I have a good amount of water available either in the rivers or streams or actually lakes or groundwater. But I have only meteorological drought. But not, this is actually surplus. Then you will actually have onset of the drought. That means drought is actually first started. Then what happens? This climate water deficit slowly propagates so that the surplus water will slowly goes down and you will end up with reduced water levels. That results in the peak drought scenario. Then after what happens when there is a water rainfall that has been filled, then you will have climate surplus, but the terrestrial water is there. Then it results in the termination of the droughts. So what we have defined is actually that drought onset, peak, and termination are because of the imbalance between the climate water deficit and terrestrial water storage deficit. Means initially your reservoir or your basin is completely terrestrial water storage, you have surplus availability of water in the basins and all, but there is a meteorological drought that triggers the drought, and this, because of this, slowly this will also goes down, because there is a drought condition, you keep using huge amount of water resource, so the terrestrial water will slowly goes down. So this condition plus this condition, there is a climate deficit because of the excess use of the water, then there is also terrestrial water that will result in the peak, and slowly the meteorological drought is actually replaced with the rainfall, and then you have climate surplus, but this shortage that results in a termination of the droughts. So knowing this, actually, then we have defined there should be some index. There should be some index to define this terrestrial water storage deficit. So for that, actually, what we have done, we have actually used Clayton-Coppola function. We have used Clayton-Coppola. Clayton-Coppola is actually one form of a coppola which mainly marginally combines the lower tiles, because the droughts are predominantly lower tide dependent. So we consider actually P minus PET to define the climate water deficit, and terrestrial water storage also we have defined using two variables U and V, and then define the integrated water index. Integrated water deficit index is something which combines all the indices to get the one unique value for this one. So for this, actually, what we have done, we have taken the climate water deficit, which is P minus PET, and we also took the terrestrial water storage, which is actually the combined variables or combined storages of all forms like groundwater, deep groundwater, soil moisture, canopy water, water in the streams, rivers, and also the atmospheric water. Then for each basin, for the same river basin, we have plotted the climate water deficit, and also we have plotted the terrestrial water storage deficit index like this. Then we have defined the IWA, integrated water deficit index, by combining these two using Clayton-Coppola. This is how IWDA varies from IWDA varies for the entire basin from 2003 to 2017. If you observe, actually, these are actually the drought periods. These are actually the drought periods. This is a wet period. This is a wet period. This is decent wet period, normal periods, and so on. So we observed that low accumulation periods captured the peak intensities, mainly IWA 1, 3, and so on. High accumulations have resulted in the prolonged periods. Among all, Upper Bhima remained the drought hotspot with high intensity. So the Upper Bhima is, if you observe, actually, it's pretty much drought hotspot every time, more or less every time. And this is how actually for each sub-basin, say for example, Upper Bhima, Lower Bhima, Upper Krishna, Middle Krishna, Lower Krishna, Upper Tungabhadra, and Lower Tungabhadra. When there are 3 events for Upper Bhima, first, second, and third, this is the start and end of the droughts, 2nd August and 5th August. Of course, year is also there. The duration is 33 months. Severity is this one, intensity is this, peak happened on this, peak intensity is this one. Instantaneous development speed, at what rate the drought is developing, at what rate the drought is recovering. These are all negatives because it's a negative slope. This is all recovering because it's a positive slope. What is the time to peak? Means in 11 months it is actually reaching the peak, and in 21 months actually it is reaching the recovery. So this is how we analyze all the droughts using the integrated water deficit index for all the sub-basins. Then what is the influencing hydrometeorological factors? So we consider many parameters like TWSI, precipitation, temperature, pressures, groundwater levels, NDVA, soil moisture, and all, and so how they are actually influencing. UP-UK-UT recorded 9 droughts with a prolonged duration. So lower basins have recorded higher number of dots with low duration. SPA showed an immediate, means what are the role of SPA, SRA, SSMA, and so on these factors we analyzed. Then what is the impact of the droughts? So we observed that water bodies and crop production are strongly correlated because more is a crop production shrinkage. Means this is a positive because more is a water body, more is actually the crop production. During the devastating drought of 2004 and 16-17, a reduction in the water intense rice production. So during the drought, there is a reduction in the water intense rice production was observed clearly. And then lower Tungabhadra has a continuous decrease in the water bodies. How this, see for example, this is how different factors are influencing both the TWSI and also SPA, because these two are combinedly resulting in the integrated water deficit index. So this is actually how the integrated water deficit index, because of this one is storage, one is climate deficit, as we discussed. The conclusions out of the work: the combined effect of climate water and terrestrial water storage anomaly is essential to quantify droughts. That means you cannot ignore some specific components because they are contributing. Spatio-temporal variation in the upper subbasins like Upper Bhima, Upper Krishna, Upper Tungabhadra has a cyclic variation, whereas for the lower version, it has witnessed a very short and discontinuous periods. Lower subbasins experienced low severity and less duration events due to adequate water available. Because there is a good amount of water available, severity is low because drought is quickly recovered for the lower subbasins. Validation of the integrated water system is highly correlated with the meteorological, agricultural, and hydrological. That's a very important conclusion we made. That means actually the IDWA is strongly correlated with individual meteorological, agriculture, and hydrology. That means IWDI, what is we developed, is representing the combined effect of all the indices. Integrated water clearly captures the drought's impacts on the reduction in the water availability. So, future scope: how can someone can still further determine the rate at which development and recovery for the seasonal droughts precisely can be extended. For example, we spent less time in terms of analyzing the drought development and recovery phase someone can take up. With the availability of the data at final resolution, effect of the drought on a seasonal dependence can be considered. And we can extend this study by considering other influencing factors derived from hydrological and agricultural indices. We are not considered all. And spatial propagation of the drought using complex network approach and analyzing the seasonal dependence could help in this. What people are doing now a lot. So with this, I will thank the audience, and the floor is open now for the questions. Hope you can hear me. Thanks.
Uh, requesting all participants, if you have any questions, please ask Dr. Panindra sir.
I have shared a few material also with Sombab Garu, so you can access those material also to get more insights into drought analysis and propagation and their studies, some research studies on that one. Hope you understand what I understood, what I discussed. Any questions? The floor is open. Maybe I can take one more quickly. I can just go through the paper that we recently published. This is actually the work that I'm talking about. It's just published only 24th June, just a week. No, 20th November. So it's just published about 10 days back. So what we have done for the same, actually, I can actually quickly go through. I already shared. This is actually the study area that I've already presented. So what these are the basins, and these are the basin characteristics. So what is the average elevation, slope, number of various hydro water storage structures, and so on. Then this is how we define the cupola. So cupola of two functions u1 and u2 is because of u1 and u2. So u1 and u2 corresponds to the two variables. For example, we took the precipitation from IMD at 0.25 scale, evapotranspiration from MODIS data, runoff from Central Water Commission, soil moisture from GLDAS, NDVA from MODIS, land use and land cover from MODIS, and for groundwater levels we took from the Central Groundwater Board. Then this is how we define the deficit as precipitation minus PET, and then that will help you to calculate the SPA. Then this is how we have calculated the integrated hydrological drought index, which combines stream flows index, which is lowering of the water levels, and groundwater level index. So what we did, stream flow index and groundwater index combinedly results in the integrated hydrological drought index. Then for agricultural drought index, we combine VCA, which is vegetation condition index, and also the SSMA, soil moisture index. So standardized soil moisture index. So we are defining that agricultural drought is not only because of the soil moisture reduction, but also reduction on the vegetation condition. So again, we defined on a standard normal. That is why -1 to +1 means it's a -1 to -0.5 is a mild drought, -1 to -1 is a moderate drought, -2 to -1.5 is severe drought, and less than -2 is extreme drought. So we are not dealing with positive values because only we are looking at the deficit values. And this is how actually, so what we have done, we did the analysis. First, we calculated the SPA accumulated at 1, 3, 6, 12 and C. And then we actually defined the run theory, the results I have presented. Then this is how actually the basins, each sub-basin is actually experiencing the droughts. Then this is how we combine the two variables. For most of the thing, actually we fitted actually the inverse Gaussian cupola, log normal, okay, Pareto model, and so on. Different distributions we have fitted for both. This is for actually the stream flows and groundwater levels to calculate the integrated hydrological drought index. This is for soil moisture and vegetation context to get the IADA, integrated agricultural drought index. Then this is how actually the correlations are actually happening, and then this is how actually the factors are influencing. So based on this is what actually one of the paper that I shared also. This is what the second work is on integrated water deficit index, which is currently under review. So I'm unable to share that one. So we'll stop here and open the floor for questions.
Sir, excuse me, sir. This is Ganesh from Ramchandra College of Engineering. Sir, I have one question regarding can you use the satellite images to predict drought?
Yes. See, drought, whether it's a meteorological or hydrological or agricultural drought, it is caused by some specific variables. As I told, meteorological by precipitation and evapotranspiration, hydrological by stream flows and groundwater levels, agricultural by soil moisture and vegetation condition. If you can, of course, there are many studies which uses the satellite-based analysis for the droughts. Mainly, one good thing with that actually, you have a repeated coverage, right? So, but only thing is, it all depends on the spatial resolution. But yes, you can use the satellite-based imageries to characterize either meteorological or hydrological or agricultural droughts.
Yes, sir. Thank you.
Sir, thank you so much, sir. On behalf of all our participants, I would like to extend our sincere thanks for your excellent session today. Your insights on we are incredibly valuable and throughout provoking. We truly appreciate the time and effort you dedicated to making this session both informative and encouraging. Thank you once again for your valuable in contribution to the success of this program. Thank you so much, sir.
Yeah, thank you very much. Thank you all of you. And yeah, you're good to contact me anytime through email. I'm okay to discuss more about actually if you have any research interests or some other relevant to droughts. Okay, drought characterization, analysis, and propagation. Thank you very much, and thanks for the opportunity.
Thank you, sir.
Yeah, thank you. Thank you.
All the participants, please stay here. The last session of this FDP will start within 5-10 minutes. I'll have to stay here. Requesting all participants, please stay here. The last session of the FDP. The speaker is Dr. Vikas Punia sir will join within 10 minutes. Requesting all of you, please stay here. Sir, good afternoon, sir. Good evening, sir. Sir, Vikas, sir. Sir, am I audible? Sir, please unmute yourself, sir. Unmute yourself.
Okay, right now you can hear me?
Yes, sir. Yes, sir.
Okay.
Okay, sir. So, dear
So,
participants, welcome to the final session of our faculty development program. Throughout the program, we had insightful sessions, engaging discussions, and valuable learning. Today's sessions will provide the perfect opportunity to wrap up everything we have learned and discuss any final thoughts or questions. We are grateful for your active participation and commitment. Let's make this final session as engaging and productive as the rest. It is great privilege to welcome to Dr. Vikas Punia. Dr. Vikas Punia is an assistant professor at the Center of Excellence in Water Management, MANIT Bhopal. Before joining MANIT Bhopal, he served as an assistant professor in the Department of Civil Engineering at the NIT Calicut, Kerala. Dr. Vikas Punya completed BTech in Civil Engineering from MDU Rohtak University, followed by an MTech in Water Resources Engineering from NIT Bhopal. Dr. Punya earned his PhD in Water Resource Engineering from the IIT Indore. After completing his doctorate, he joined the Indian Institute of Science, Bengaluru as IOE postdoctoral fellow, serving from March to October 2022. Further, he worked as a postdoctoral fellow in the Department of Earth Sciences at USA. Dr. Punia has published over 15 research articles in the prestigious journals, along with 8 book chapters in Springer and CRT Press and 3 technical reports. Recently, he was awarded the GM Navate Puraskar 2024 by ISH. Sivaparan Young Scientist Travel Award by the International Association of Hydrological Sciences. The Professor UC Kotyari Best PhD Thesis Award for 2022 by Indian Society of Hydraulics and the Best Paper Award at the Hydro 2023 International Conference by ISH. Additionally, he has received several Young Scientist and Best Paper Awards at international conferences during his doctoral research. In his undergraduate studies, he was honored with a gold medal, the Best Outgoing Student Award, and overall academic award. We are truly privileged to have a expertized personality with us today. Please join me in welcoming Professor Dr. Vikas Punia to share the knowledge and expertise with us. Requesting Dr. Vikas Punia, sir, please start the session.
okay, thank you, sir. So first of all, before starting my presentation, I would like to thank you for giving me this wonderful opportunity to present my research work on this Atal FDP program. And thank you so much for the nice introduction. So I'll share my screen. My screen is visible.
Yes, sir. Yes, sir.
Okay. So shall I start?
Sir, please start, sir.
Okay, thank you so much. So first of all, I'll introduce myself. I'm Dr. Vikas Punia, Assistant Professor at the Center of Excellence in Water Management, NIT Bhopal. And in this AICTC Atal FDP program on this disaster risk reduction through sustainable infrastructure, I'm presenting my work related to the drought disasters and its ecosystem. So the title of my presentation is Novel Methodology for Detecting the Disasters and Assessing the Ecosystem Impacts and the Resilience across Indian river basins. So as part of this work has been carried out at ISC Bangalore and some part has been carried out at Purdue University, USA. So I'm acknowledging both the institute along with my institute, that is Manit Bhopal. So in this lecture, I'm not discussing about the simple droughts as we know about, like meteorological, hydrological or agricultural droughts, because these are very conventional droughts. And from last 50 years or more than 100 years, we are focusing on these droughts, and we have a lot of published papers and research for these types of drought. But recently, from last 5 to 7 years, we have a term related to flash drought. So I will discuss that flash drought and what the definition or methodology we can develop for this. I will discuss that. Okay, sorry. So let's try to understand what is the extreme conditions existing over India. What is the current situation or current condition of hydroclimatic extremes over India? So if we talk about the flood, more than 40 million people are affected by the widespread flooding in the Indian subcontinent. If we talk about the last 4 years, like 2015, 16, 18 and 19. Other than that, if we talk about the warming condition across India, India is continuously witnessing warmer seasons across last 20 or 30 years. And if we talk about the 15 warmest years, we found that 11 out of 15 warmest years were only in the last 15 years. That is from 2007 to 2021. And this data set has given by IMD, that is India Meteorological Department. So it is very alarming situation for us that out of 15 warmest year, only out of 15, only the 11 are only from the last 15 years. It means we can say that last 15 years are highly vulnerable for us in terms of warming conditions. Similarly, due to this warming situations, we have problem of heat waves. If we talk about only the 3 months of recent year or current year, that is 2024, from March to May, we have more than 56 heat related deaths and more than 25,000 heat strokes, which are reported in from March to May only. If we talk about the extreme conditions or extreme rainfall events, a study has been carried out in 2027 by the Roxy et al. In 2017, and they found that there is thrice increase, or we can say 3 times increase in the extreme rainfall events across India from 1950 to 2015. It means from 65 years, we have increased these extreme rainfall events by the 3 times. So by looking all these data sets as per the hydroclimatic extremes, we can say that due to large population and high economic activities, India is at high risk of disasters. These disasters can be climatic, geologic, or human-induced disasters. So by looking at this, we can say that India is at high risk. So we must consider a lot of studies related to disaster reduction and its resilience across India. So let's discuss why we need to carry out the work related to droughts. So as we know that due to greenhouse gas emissions and increasing CO2 concentrations, there is a change in climatic conditions. And if we talk about human influence, there is a change in land atmospheric interactions. So these combined effect of change in climatic conditions and change in land atmospheric interactions will result in several impacts, like change in magnitude of precipitation, increase in temperature, decrease in relative humidity, soil water deficit, or the depletion of groundwater. And all these impacts will result in various possible extreme events like floods, droughts, extreme rainfall, atmospheric warming, heat waves. Out of which my study is much more focused on droughts because there are several risks which are associated with drought, like it reduces arable land productivity, it declines, or it causes rapid reduction in the soil moisture. And this rapid reduction in soil moisture during the drought itself give a new type of extreme weather event which is termed as flash drought. So let's understand what is flash drought. So from last 5 to 7 years, if we talk about that, there is a new term related to flash drought. Before I think 7 years or 8 years, there is no terminology related to flash drought. If we are researcher and if we are doing work or research work related to droughts and flood, we are very easily we can find a term that is flood, drought and flash flood. But from recently 5 to 7 years itself, we got a new term that is flash drought. So let's try to understand and try to find out what is the research related to this. So I found a lot of news clips from different sources, and as per these clips, they suggest that flash drought are a new type of extreme weather event. Some of the study says that flash drought are a new type of climate change effect. But the problem with the things that one of the study which has been carried out at New England, they found that even the damp condition or humid conditions are also hit by the flash drought. As far as we know, as in terms of drought condition, what we have a perception that mostly the arid or a semi-arid regions are more vulnerable or more sensitive to the drought conditions. But here in this study which has been carried out at New England, they found that the humid conditions, or we can say humid or semi-humid area of New England are also hit by the flash drought. Then further, the study has been carried out for future prediction, and in the future flash drought conditions also, they found that these events are increasing over the humid regions in the future. So this is highly alarming situation, because we know that mostly the arid and semi-arid regions of India are vulnerable to drought-prone conditions, and the policy makers of India are making the policy for the arid and semi-arid regions whenever we are talking about the droughts. But here it is not like that. In England, we are getting the news that mostly the humid regions are also hit by the flash drought. So as a researcher, it's our duty that we need to check whether the humid regions of India are also hit by the flash drought or not. And if we want to visualize the effect of flash drought, let's see these two photographs. These two photographs are taken in USA, America, and these two photographs are taken in the span of 40 days or 41 days. The first photograph is taken on 1st July of 2012, and second is taken on 11th August of 2012. And within only for the span of 41 days, you can check the condition or check the impact of flash drought. The first figure is showing a very greenery condition, but due to flash drought, within only 41 days, it causes a huge damage. If we talk about the traditional conventional drought, the same effect of condition is caused by the traditional drought within a month, 6 months, or more than a year. But the same effect has been caused by the flash drought within a very few days, like 41 days or 40 days. So based on all these recent news, it is suggested that we need to carry out more studies, and faster forecasting is required to fight against the flash drought conditions. So let's go for the flash drought condition and its computation across India. So if we talk about India, India is one among the most vulnerable drought-prone countries in the world, with at least one drought occurred in every 3 years in the last 5 decades. But this statement is much more focused on the traditional droughts, or we can say conventional drought, like meteorological, hydrological, or agricultural drought. But recent research revealed a new type of extreme weather event, which is termed as flash drought. And these flash drought and conventional droughts are completely contrast to each other, because traditional drought are a very slow growing climate phenomena. They take few months, sometimes seasons, or sometimes year also, in order to attain their maximum intensity or a spatial extent. But in contrast to these traditional drought, flash drought is a very fast growing climate phenomena, and they are characterized by quick onset and rapid intensifications. So let's understand what is quick onset and what is rapid intensification. Quick onset means the initial stage or the onset of this drought is very quick, very fast, and there is a rapid intensification, means at every scale the intensification of this flash drought is very high. So these two are the major characteristics, that is quick onset and the rapid intensification. And due to this, it causes a quick reduction of soil moisture. And this quick reduction of soil moisture further causes vegetation stress. So due to this, I have carried out this study, and for the very first time, I have developed a novel approach to define the flash drought based on the aridity index. So I have developed a definition for finding out the flash drought over India, and before me, there is no definition of flash drought based on the aridity index. And for the very first time in India, flash drought impact on terrestrial ecosystem across Indian river basin was also investigated in this analysis. So these are some of the data sets which we have used in this study, like precipitation and temperature. So precipitation and temperature I have obtained from India Meteorological Department, and they are available at a different temporal spatial resolution, that is 0.25 degree into 0.25 degree and 1 degree into 1 degree. Other than that, I have obtained the Delhi potential evaporation data set, and this data set we have taken from GLEAM dataset, that is Global Land Evaporation Amsterdam Model, that is GLEAM dataset, and the version is used as 3.5a, and the resolution of this dataset is also 0.25 degree into 0.25 degree. Other than that, we also need to have the data set related to wind speed, which is taken from Terrestrial Hydrology Research Group, Princeton University. Relative humidity dataset is also obtained from NCEP or NCAR reanalysis dataset, that is National Center for Environmental Prediction or National Center for Atmospheric Research. Other than that, we need to take the soil moisture dataset. But the problem with soil moisture dataset across India that we do not have any observed or any in situ soil moisture dataset for India. So we cannot rely like precipitation and temperature we will get from the IMD, but for soil moisture we don't have any such data set. So what we need to do, what I have done, I have taken the soil moisture data set from 5 different soil moisture products. Like first one is European Space Agency Climate Change Initiative Soil Moisture Combined Data Set. Second is from GLDS, that is Global Land Data Assimilation System. Third is ERA dataset, that is ERA Interim Soil Moisture Reanalysis Product. The fourth one is the MERA dataset, that is Modern Era Retrospective Analysis for Research and Application version 2. And the fifth one is from India, that is Indian Monsoon Data Assimilation and Analysis Soil Moisture Dataset. So why I have taken the 5 different ones? Because we are not confirmed whether which dataset is best for us. So what I have done, I have taken the soil moisture from 5 different sources and apply some technical approach through which I will select the best one for India, and that best one I will use for the further classification or further soil moisture flash drought computation. And the last thing is GPP dataset. Why we have taken the GPP dataset? Because we need to find out the impact of flash drought on the terrestrial ecosystem. And for the terrestrial ecosystem, I have used GPP, that is a gross primary productivity, as a terrestrial ecosystem indicator. And this GPP dataset I have taken from the MODIS dataset, that is Moderate Resolution Imaging Spectroradiometer. And this dataset is available at 8-day temporal resolution. So all the above dataset like precipitation, temperature, Delhi potential evaporation, wind speed, relative humidity, soil moisture, all the dataset are available either on the hourly form, 3-hourly form, or daily basis. But the problem with GPP dataset that it is only available at 8-day. So we cannot use the dataset at a different resolution. Either it is spatial resolution or temporal resolution. So what I have done, I have converted all the above dataset except GPP to the 8-day temporal resolution. So at the end, we have all the dataset at the same resolution, that is 8-day temporal resolution. So dataset in the temporal resolution is same. Either it is precipitation, temperature, potential evaporation, wind speed, relative humidity, soil moisture, and GPP. All are converted to 8-day. Then the problem comes with the spatial resolution. So spatial resolution, you can see from the figure or table that it is at different resolution like 0.12 degree, 0.5 degree, 0.75 degree, 0.05 degree. So what I have done, I have converted all the data set into a 0.25 degree into 0.25 degree resolution. So finally, all the data set are available at 8-day temporal resolution and 0.25 degree to 0.25 degree resolution. So we can say, yes, all the data set are at same resolution. Either it is temporal or spatial resolutions. So once we have the data set, let's start to discuss the study area. So this study has been carried out at 25 major river basins of India, and these 25 major river basins are classified as per the India Varis 2014 classification. And here, these are given as notation, like one is showing the Indus, 2A is showing the Ganga basin, 2B is showing Brahmaputra, 2C is Barak river basin. Similarly, Godavari, Krishna, Kaveri, Subarneka. B stands for Brahmani and Vitarni river basin, Mahanadi, Penar, Mahi, Sabarmati, Narmada, Tapi, and these short forms. And these short forms I have discussed here, like EFRMGB is the east flowing rivers between Mahanadi and Godavari basin, and finally we will come for the Western Ghats. Similarly, like this. Then, since we got the data and the study area we have finalized, let's start the discussing what is the methodology, how we can carry out the work related to flash flood. So initially we have collected the data set from 1981 to 2021, around 41 years, in the form of precipitation, daily potential evaporation, temperature, relative humidity, soil moisture, out of which we have calculated the aridity index, that is ratio of precipitation to the potential evaporation. This is aridity index. This aridity index, once we calculate, then we will go for the flash dot identification using AI. Once we have aridity index value, we can use that aridity index for the flash dot identification. But here, one thing which is very important to discuss, that the direct value or the absolute value of AI cannot be used for flash dot identification. Whatever the value of aridity index we have to convert this aridity index values into the percentile form. If we convert it into the percentile form, then only we can start the flash dot identification, because whatever the definition I have given, that is based on aridity index percentile, not on the absolute value of AI. In the flash dot identification, I have 4 objectives, or we can say 4 sub-objectives to discuss. The first one, once we have the flash dot identification, we will find out its characteristics, like its frequency, its duration, and its maximum duration, minimum duration, or average duration. The second thing is intensification rate, means at what rate the flash dot is intensifying. And finally, the third is the triggers, or we can say the drivers of the flash dot. Means what are the variables, what are the major variables which causes flash dots across India. So we have to discuss the characteristics, the intensification rate of flash dot over India, and the major drivers or the triggers of the flash dot across India. The second sub-objective is to determine that how hydrometeorological conditions are behaving during and after the flash dot. It means hydrometeorological conditions means simply we can say the soil moisture, the temperature, the precipitation, or vapor pressure deficit, how they are behaving during the different stages of flash dot. Because why we need to find out this? Because if we are developing any definition for any extreme events like flash dot, whatever we have developed, whether it is validated or not, for that we are validating with the hydrometeorological conditions. If we are saying that as per our definition, during this 15 days or 20 days, if there is a flash dot event, what is the condition of hydrometeorological behavior variables during that stage? Either they are also behaving in the similar pattern or not. So this is the reason why I am showing the hydrometeorological conditions during, before, and after the flash dot. The third objective is to determine the ecosystem response to the flash dot. Means how our ecosystem is responding, whether our ecosystem is affected or not, whether this flash dot is having that capacity that it can affect our ecosystem or not. And if like that, we have to also find out what is the response of water use efficiency or underlying water efficiency to flash dots. Here, I need to discuss only one thing, because I have used a new term, that is UWEE, that is underlying water use efficiency. From last lot of years, we are very common term we are using, that is water use efficiency. That is simply, if we have GPP data sets, GPP divided by evapotranspiration will give you water use efficiency. But the problem is that I found from one study in 2014 that whenever we are computing water use efficiency, on an annual scale, whatever the formula we are using for so long, that is GPP divided by evapotranspiration, the water use efficiency results performs very good. But whenever we are computing this water use efficiency value at a very finer scale, like daily or sub-daily time scale, that then we cannot use this formula. We have to add one important parameter, that is vapor pressure deficit, that is VPD. And if we are incorporating this vapor pressure deficit in the calculation of water use efficiency, then that water use efficiency is known as underlying water use efficiency. So if you have the data set related to anything based on daily or sub-daily time scale, please don't calculate water use efficiency directly. You have to include this vapor pressure deficit. And that water use efficiency is known as underlying water use efficiency. So this is all about the methodology. So what we have done, we have calculated the aridity index, and that aridity index is used for flash dot identification. But we are not confirmed how we can calculate the flash dot. So let's discuss the computation of flash dot using AI. So as far as we have AI value, that is aridity index value, convert into the aridity index percentile values. Please don't use directly AI values. Absolute value will not help you to find out the flash dot. So once you have AI value, please calculate the percentile values. And once you have done, you have to go for this definition or this methodology. And in this methodology, I have 4 conditions to satisfy. We have 4 conditions. We need to check each and every single conditions. And if all 4 conditions are satisfied, then only we can say, yes, this particular dot event is a flash dot event. So let's go for the first condition. The first condition is that current aridity index percentile should be less than 50th percentile and prior should be greater than equal to 50th percentile. It means the current should be less than 50th percentile and prior should be greater than equal to 50th percentile. It means we have a threshold of 50th percentile, and in this we have to come from above 50th percentile to below 50th percentile. This is the first threshold. So we must go from above to below 50th percentile. If this condition is true, then we can say, yes, we can begin the flash dot identification, and we can go for the second condition, that mean decline rate of this aridity index percentile should be greater than equal to 5%. Why I am putting this condition? Because in the initial definition itself, I have declared that it should have rapid intensification. So this decline in soil moisture or any aridity index percentile should be greater than equal to 5%. It means it should have high decline rate or high intensification rate. And if this condition is true, we can increase the time count until unless it gets false. Once it gets false, we have to come for the third condition, and it is very important that this aridity index percentile should below or fall below the 20th percentile. Why? Because the first threshold is 50th percentile and second is 20th percentile. If it is not going below the 20th percentile, we cannot say it is a flash dot event, because it is not crossing the second or the lowest threshold. This is the lowest threshold. If it is not going below 20th percentile, it can be a drought, like a traditional drought, but it cannot be a flash drought. So if third percentile or third condition is true, we can increase the time count until unless it gets false. And if it is false, let's go for the fourth and the final condition. And the final condition says that total drought duration should be greater than equal to 3 time steps. And since in the data set itself, I have declared that 1 time step is equal to 8 days. So 8 into 3 should be 24 days. So total duration of flash dot should be greater than equal to 24 days. And if this fourth and final condition is also true, then we can say, yes, that particular event is a flash dot event. Otherwise, we will clearly say that it is not a flash dot event. It can be an event. It can be simple drought like traditional drought like meteorological, hydrological, or conventional drought, but it cannot be a flash dot. So this is all about the flash dot methodology. So after going this, let's discuss what are the climatological characteristics across India. So since we are not very well aware about the climatological conditions across India, so before going deep into the results, we need to understand how the climatological characteristics across India play a significant role. So this figure I have simply shown the spatial distribution of annual precipitation, soil moisture, gross primary productivity, water use efficiency, and underlying water use efficiency across India on an annual scale. And what we found that if we talk about the precipitation, we have high spatial temporal heterogeneity in the terms of precipitation across India. You can see some part of India is having precipitation greater than 3000 mm per year. You can see in the northeast India or western Ghats, and in case of western India you can see this value is ranging less than 100 mm per year. So this is the heterogeneity of India in terms of precipitations we have. And if we talk about the soil moisture, very dry conditions of soil is found across central and western India. If we talk about GPP or water use efficiency, what we know that these value of GPP and water use efficiency is higher in northeast India, like the northeast part, and this is minimum across western India. And why the condition is like that? Because highest in northeast India, because we know that northeast part and the western part of India is highly covered with forest. However, in terms of western India, we found that these values are minimum because of low productivity and high evaporation demand, or we can say high demand of evapotranspiration. So these are the climatological characteristics across India. So let's understand what are the results we got for the flash flood. What are the results for the flash flood? So here I have shown the seasonal distribution of flash flood frequency across Indian river basins. So what I have taken 4 seasons: winter, pre-monsoon, monsoon, and post-monsoon seasons. That is defined by the India Meteorological Department. Winter is ranging from Jan to Feb. Pre-monsoon is ranging from March to May. Monsoon is from June to September, and post-monsoon is October to December. But the problem what I face during the competition, that some of the event start in, for example, in winter and ending into or terminating into pre-monsoon. Some of the events start in pre-monsoon and terminating into the monsoon season. So I am confused whether it should be in the pre-monsoon or it should be counted in monsoon season. So if we are taking any one of them, it is not a true event. So what I have done, I have taken 4 another season, that is a transition seasons from winter season to pre-monsoon, pre-monsoon to monsoon, monsoon to post-monsoon, and post-monsoon to winter season. So in total, I have taken the 8 season, and what I found that during the monsoon season, majority of the India is showing low likelihood of the flash flood events. Means in the monsoon conditions, we don't have any problem related to flash flood. But if we talk about the highest frequency of the flash flood, that is observed in post-monsoon season, followed by the transition seasons. And why the flash flood frequency is highly occurring in the post-monsoon season? Because during that period, there is a long dry spells with negative precipitation anomalies. And this long dry spell with the negative precipitation anomalies causes rapid reduction in soil moisture. And this soil moisture reduction will trigger the flash flood across India. So this is the results related to frequency. Means what is the number of events of flash flood across India. Then discuss the intensification. Means at what rate these flash floods are intensifying across India. Means the rate of intensification. And higher the rate of intensification, higher will be the problem for us. So here I have shown the intensification rate across all the river basins in the 41 years from 1981 to 2021, and I have classified like 5%, 10%, 20%, and more than that. And what we found that flash flood events with high intensification rate are more common in humid regions like northeast India rather than semi-arid regions like western India. As far as if we are working on drought conditions or drought problems, we are very well aware about Indian condition that mostly the arid or semi-arid regions like Western India or Rajasthan are more vulnerable or more sensitive to drought conditions. But here we are getting the opposite of that. Flash flood events with high intensification rate are more common in humid regions or semi-humid regions like Northeast India or Western Ghat rather than semi-arid regions like Western India. And same I have shown you in the motivation slide where I have discussed about the New England study. So similar type of pattern is observed in India where the high intensification rate of flash flood are more common in humid regions, not in semi-arid regions. So based on that, we can suggest that that anthropogenic climate change has altered the traditional climatic regions. We need not to stay on that traditional climatic regions and old policies. If we are discussing about the flash drought, we need to give more focus on humid regions and semi-humid regions rather than arid or semi-arid regions. So we need to change our policy. If we are talking about the flash drought risk, then we have to give some more priorities to the humid regions or semi-humid regions, because this climate change has altered the traditional climatic regions of India. Then let's discuss what are the major drivers or major triggers of the flash drought. So when I am selecting the triggers or drivers, I have to go for the literature review, because I don't know what are the major possible drivers of the flash drought. So when I found from the literature, when I have done the literature review, I found that some of the study are calculating the flash drought based on the precipitation. Some of them are calculating based on the temperature, and some of the studies, or mostly more than 50% of the study, are calculating the flash drought based on the soil moisture. So I am not confirmed whether the precipitation, temperature, or soil moisture can be a trigger for the flash drought in India. So what I have done, I have taken all three, that is precipitation, temperature, and soil moisture. But when I'm selecting these, I have kept in the mind, might be they are behaving as a trigger individually, or they can be behave as a trigger in the combination. So what I have done, I have taken the precipitation, temperature, and soil moisture as individual triggers, and then their combinations. So if we have three things, we have to make the combination like precipitation, temperature, then precipitation, soil moisture, then temperature, soil moisture, and it can be possible that all three can act as a trigger simultaneously, that precipitation, temperature, and soil moisture act collectively to act as a trigger for the flash drought. So what I have done, I have taken precipitation, temperature, soil moisture, and their combination like precipitation, temperature, precipitation, soil moisture, temperature, soil moisture, or the combination of all, that is precipitation, temperature, and soil moisture together. So let's discuss what are the major triggers we found across India. So in majority of the India, you can see from the figure itself that the combination of precipitation and temperature, you can see from the figure, that is a sky blue color, and from there itself you can see that precipitation plus temperature, means combined effect of these, are playing or acting as a major trigger or primary trigger of the flash drought across majority of study area. And in some part like Northeast India and Western Ghat, the individual effect of soil moisture and precipitation. In case of Northeast India, soil moisture is acting as a primary trigger, or individual effect of this soil moisture is acting as a trigger. And in case of Western Ghat, the precipitation is acting as a major trigger across Western Ghats. Then we have calculated everything related to flash drought. Then we need to have data sets related to soil moisture, because once we have the soil moisture data set, then only we can say that whatever the definitions we have developed and whatever the flash drought events we have claimed, whether they are correlated or validated by the hydrometeorological variables or not. And for hydroclimatological variables, we need soil moisture data set. So since we don't have in situ soil moisture data sets, so what we have done, we have taken the soil moisture from different sources, like 5 different sources, and from that 5 sources we have to apply some technical approach through which we can find out the best soil moisture data set. And once we have the best soil moisture data set, that data set can be used for the validation purpose. So initially, I have taken all the soil moisture data set from different 5 sources, and I have applied a triple collocation approach. And this is really a very good approach. If you have a confusion of the data set in any of your field, if you have a problem with the selection of the data set from different sources, please go for the triple collocation approach. It is very simple approach, and it will give a very good results whenever you need to select any one of the data set as the best soil moisture, or any of the data set from any sources. So the process of this, that it is known as triple collocation. Why it is triple? Because it make the triplets at a time. Initially, it will not take all the 5 or 6 data sources at the same time. At a single time, it will take 3 data sets. Like in the first row, you can say triplet 1. At that time, it is taking only 3 data sources at a time. Second triplet, it is taking 3 data sets. In the triplet 3 also you can see 3 data sets. So every single time it will make the triplets of different combination like 1 to 3, 1 to 4, 1 to 5, 1, 3, 4, 1, 3, 5, similarly like this. And it will make the triplets of all the combination possible, like from permutation and combination. And based on that, it will calculate the RMSE value and correlation coefficient values. And the major advantage of this approach is that it will not sorry, it will not treat any of the 5 data source as a perfectly observed truth, because the thing and the problem with us that we will consider any one of the data source as a perfectly observed truth. But since we are not confirmed which one is the best one, so we will not consider any one of the data set as perfectly observed truth. We will create an unknown truth. And based on that unknown truth, we will calculate the RMSE value and correlation coefficient value for all the triplets. And based on the triplets, we will compute we will find out the best soil moisture data set. So from these figures, we got to know that GLDS, NOAA soil moisture, and the ERA data set are performing better as compared to other 3 soil moisture products. But anyhow, we have to select one. So we have selected GLDS because it is performing slightly better than ERA dataset, as well as with the ERA dataset, there is a problem that there is missing soil moisture datasets values in this dataset. So finally, we have selected GLDS from the triple collocation. And if after this slide, whatever the soil moisture dataset I am discussing, it is only taken from the GLDS, not from the other sources. Then we are going for the second sub-objective of this research, where I will discuss the validation of my definition. Whatever that definition I have given for the flash load, whether that definition is validated or not. So here I have shown the hydrometeorological conditions at different stages of flash load. If they are aligning with my definition, then we can say yes, my definition is purely validated, otherwise it's not. So here I have taken 4 variables, that is soil moisture, precipitation, temperature, and vapor pressure deficit. And I have taken 4 stages. The first row is showing before the flash load. Second one is showing the initial stage of flash load. Third row is showing the last stage of flash load. And fourth row is showing the after the termination, after the completion of the flash load. Means before flash load, after flash load, and during the flash load, how these variables are behaving. And from the figure, if we talk about the first column, before the flash load, soil moisture condition is very good. It is completely green, and it is up to 50th percentile. And 50th percentile of soil moisture value is very high, and it is very good for the normal greenery conditions. But once it enters into the flash load, this soil moisture percentile decreases, and it reaches from 50 percentile to 41 percentile. It means once the flash load starts, soil moisture starts decreasing. And to the last stage of flash load, this soil moisture causing a quick transition, and it leads to a much drier condition, and ranging from 41 percentile, it is directly coming to 19 percentile. It means it is showing high quick transition, and it is going to the much drier conditions. Means from 50th percentile to 41, and 41 to 19 percentile. This is the effect of flash load, and this is the effect of flash load on soil moisture. And after the termination, this soil moisture recovers very quickly, and from 19 percentile it increases to 36 percentile. So this condition itself validate our study that before the flash load, our soil moisture is very good condition, but during the flash load, it is leading to much drier condition, and after the termination, it recovers very quickly. And if we talk about the precipitation and temperature also, we can see from the figure that during the flash load, precipitation is more than below than the normal value. Whatever the average value of precipitation, it is more than below. You can see the red marks or red figure in the precipitation. And before and after, you can see the greenery. It means before and after of the flash load, the precipitation value are very high, but during the flash load, the precipitation value is very less. Similarly, go with the temperature. During the flash load, temperature condition is very high. Means the temperature or evaporative demand is very high, but before and after the flash load, it is very less. So all the hydrometeorological behaviors are behaving accordingly to the flash drought conditions. If we have defined the flash drought using AI, we can say that during that flash drought, soil moisture is very less, precipitation is very less, and temperature and vapor pressure deficit is very high. Before and after flash drought, these conditions are in very normal conditions. So with this, we can say our definition is highly validated. Then coming to the third and fourth sub-objective, that is ecosystem response. Means how our ecosystem is responding to flash drought. So for that, I have taken the two indicators to represent whether our ecosystem is responding to flash drought or not. So the first one is response frequency and second is the response time index. Means how frequently and after how much time our ecosystem is responding to flash drought. And it is very important to understand, because if some event or if some extreme event is occurring across India, whether our ecosystem is affected or not. And if it is not affected, we don't have any problem whether any extreme event is occurring or not. But if our ecosystem is highly affected by these events, then we must consider something and we must change our policy accordingly. So here I have used both the response frequency and response time. If response frequency is less, it is good for us. And if response time is longer, this is also good. Why response time, longer response time is good for us? Because longer response time indicates the lower risk to the ecosystem. For example, if an event occurs for 20 days and our ecosystem is not responded in 20 days, it means our ecosystem is safe for that particular event. But if if a flash drought event occurs for 20 days and for the very first 10 day our ecosystem starts responding, it means that drought event can deteriorate our ecosystem or ecosystem resilience. Our ecosystem resilience value or ecosystem resilience or adaptation can be destroyed by the flash drought events. So let's understand the results of response frequency and response time. So here I have shown the results related to response of gross primary productivity to flash drought in case of response frequency and response time. In case of response frequency, you can see from the first two figure that mostly all the part of India is showing the percentage greater than equal to 95%. It means mostly all the flash drought events are responded by the ecosystem. If any event is happening across India, our ecosystem is affected by event. So it is highly vulnerable for us. And if we are talking about the response time, there is a good signal that some part of India, like Northeast India and Indo-Gangetic Plain, you can see from the figure that is green part, it shows the response time is very high, a longer response time. And longer response indicates that our ecosystem is at a lower risk to the ecosystem. Initially, when the flash drought occur, our ecosystem will not respond. It will take some time, and after that, it will start responding. But from this figure, we are not able to get whether our ecosystem will respond or our ecosystem having lower risk to the flash drought event throughout the flash drought or not. So we have to get to know whether this lower risk to the ecosystem sustained through the flash drought or not. So let's understand this thing with the second figure, that is response of water use efficiency and underlying water use efficiency to the flash drought. So in this figure, we have two major findings. The first finding is very common for us, that is underlying water use efficiency. What I have discussed in the methodology section, that we can compute water use efficiency as normal one, or we can compute as underlying water use efficiency by incorporating vapor pressure deficit. So I have shown the response of water use efficiency as well as underlying water use efficiency. And what we can visualize from the figure, that the lower row, the second row is showing that the water use efficiency value are higher as compared to the first row. Because the first row is showing the value of water use efficiency and second row is showing the value of underlying water use efficiency. And second row, if it is very high, it means we can say that underlying water use efficiency or value are higher as compared to water use efficiency. And this is due to vapor pressure deficit. That's why I will say, whenever you have a data on a daily or sub-daily time scale, please go for the underlying water use efficiency, because water use efficiency value are not correct for the daily scales. And the second observation we have, that initially during the first stage or initial stage or onset stage of flash drought, the water use efficiency value are higher. And if we have higher value of vegetation or higher value of water use efficiency, it indicates higher resilience of the ecosystem. It means at the initial stage of the flash drought, water use efficiency value are higher, which indicates higher resistance of the ecosystem or higher adaptation of the vegetation to the flash drought. But these values are decreasing in the recovery stage or in the last stage of flash drought. It means initially our ecosystem is highly resilient or highly adaptive to the flash drought event, but this adaptation or this resilience or resistance to the flash drought is decreasing with increasing flash drought durations. So this is a problem. If we have a flash drought event of higher duration, it will create a problem for our ecosystem. Initially, our ecosystem is very high, or it is showing having resistance power of high thing, or high resistance power, or high vegetation adaptations to the flash drought. But this resistance, this resilience, or this adaptations decline with the increasing flash drought duration. So, if flash drought of high duration will affect more as compared to flash drought of lower duration to the India. So based on that, I can conclude that aridity index can be used as an effective indicator for the flash drought identification. If you want to calculate the flash drought across India, you can use this definition easily for the aridity index, which can be used, and it can helpful for calculating the flash drought across India. And it is highly validated. If we talk about the intensification rate of the flash drought, we can say the high intensification rate of flash drought events are more common in humid regions or semi-humid regions rather than semi-arid regions, because we have perception that droughts are occurring more in arid regions or semi-arid regions like Western India, like Rajasthan. But in case of flash drought, it is not like that. It is completely opposite, and it is showing high intensification rate in humid regions like Western Ghats or Northeast rather than Western India. So if as a policy maker, if they are preparing any policy for the drought, they should give attention that they should have some policy for the humid regions and semi-humid regions whenever they are talking about the flash drought events, not for the normal droughts. Third thing, if you are performing any of the study for the flash drought and you want to take some input variables for a calculation of flash drought, so you can take precipitation and temperature. These two variable, that is precipitation and temperature, are acting major triggers for the flash drought across major part of India. So if you are developing any definition or if you are calculating flash drought using precipitation and temperature, so combined effect of this will help you give better results for the flash drought and its frequency and characteristics. So please use precipitation and temperature as major triggers of the flash drought across India. If we talk about the ecosystem response, our ecosystem is highly responsive to flash drought. And if we have 100% of flash drought, more than 97% of flash drought events are responded by the ecosystem. So we can say that our ecosystem is highly sensitive, highly responsive to the flash drought events. And from the last study, from the last objective, we get to know that our ecosystem is highly resistive, showing high resilience, or the adaptation of vegetation is very high to the flash drought, but this adaptation decreases with increase in the flash drought durations. Other than that, I got to know that in this study, I have used only top 1 meter soil moisture data set as a root zone soil moisture. But through the literature, I got to know that in India itself, we have a lot of plants having roots deeper than 1 meter. So in that condition, I got confused whether this soil moisture study will be applicable for the 2 meter soil moisture data for the 2 meter plants or not, because we cannot say that all the plants have roots deeper less than 1 meter. It can be up to 1 meter, or it can be more than that. So it is very confusing whether that this study is useful for that or not. So what I have done, I have taken next time 2 meter soil moisture data set and performed the analysis again using 2 meter soil moisture data set. And what I found, results are very similar. So it is from this thing we can say that it is very reasonable to use 1 meter soil moisture data set to analyze the impact of flash drought. We need not to take the 2 meter soil moisture data set. Results are very similar. So please go for the 1 meter soil moisture data set. It will help you out. And finally, the results of this study will help or facilitates the policymakers to develop the effective flash drought risk reduction strategies and mitigation strategies for a disaster risk reduction across India. And these are the papers of this study. They have published in Journal of Hydrology and the Journal of Hydrometeorology. Thank you. Yes. Any questions? I think someone has raised the hand. So if you want to ask any question, please ask.
Good evening, sir.
Good evening, sir.
Yeah. Thank you very much, sir, for your enlightened lecture on this flash droughts and its detection and prediction, etc.
Yes.
And so regarding this ecosystem resilience, you said ecosystems are sensitive as well as resilient to this flash droughts. So that human development or the human intervention is not there, sir, in ecosystem resilience. Any impact is there on human development or society on it, sir, about ecosystem resilience?
Yes, sir. The human developed, obviously, it will affect the resilience power because the resilience power of our vegetation or our vegetation adaptations to such type of drought events are taken care by the greenery or the forest areas. And due to human development, we are just destroying or we are going for the deforestation. And due to this, it will affect the resilience or vegetation adaptation in a negative way.
No, sir.
Yes, sir.
Right. So some mathematical models you have shown, sir. What about the latest methods, sir, like soft computing, like AI and this genetic algorithms, etc.? Can you use those things and predict the forthcoming flash drought, sir?
Yes, sir. The thing is, if you apply this definition only and you will get some data set of the future, you can go for this. Otherwise, you go for AI or ML, also machine learning techniques. You can prepare a model and you can predict the future forecasting of this. Other than that, just take the aridity index or compute the aridity index and apply the same. Since this is applied for the observed data, same definition you can apply for the future. You can get the future prediction of flash drought events.
So for this soil moisture data is required, sir, no?
A soil moisture data set for future we will not get, but the thing is, since this definition
Soil
is
moisture data.
already validated, so we can use that.
Okay. Normally, groundwater data we can get from some departments and all. Where this soil moisture data is available, sir? Normally, only we have to test on our own, or any agencies maintain the data, sir?
Yes. Sir, right now we don't have any in situ or observed soil moisture data set in India. So whatever the data set provided by the satellite data sets like reanalysis products or satellite data sets, we have to depend on these data sets only. So that's why I have taken from different sources. Right now, from last, I think, recent period itself, India has developed some data sets from using the satellite images. That is IMDAA, India Monsoon Data Analysis and Data Assimilation and Analysis. This is the source from the India itself.
Okay. So they are based on some microwave or some kind of satellite, sir? Or
Satellites only. They are not observed data sets.
okay, okay.
Means
So
from
we
the
can
satellite,
we can take,
images or pictures, and based on that, they will calculate.
so we can have spatial data and we can use them.
Yes, sir. Spatial data you can take and use that.
Okay, sir.
Yes, sir.
Very nice, sir. And also, I am very much thankful to you, and I personally gained a lot of knowledge from your lecture, sir. And your lecture is also very much connected to our today's the 6 days Atal sponsored FDP, that is disaster risk reduction, and your discussion is also very apt to the current discussion, also current theme. Thank you very much, sir. Any participants, if you have questions, please ask the speaker. Otherwise, co-coordinator, please go ahead with the vote of thanks, sir. And thank you very much, sir. We will be in touch with you in for future collaboration. And
Sir, sir, thank you so much for your excellent session today. Your presentation was not only insightful but also highly engaging for all of us. The depth of knowledge and clarity you brought the topic were truly appreciated by all the participants. We are grateful for your time, effort, and dedication in making the session such a success. Your expertise has definitely enriched our learning experience, and we look forward to applying the valuable takeaways from your session. Thank you once again for your wonderful contribution, sir. Now, I kindly requesting HOD of Civil Department, Dr. K. Sundar Kumar, sir, give the concluding remarks for this session. HOD, sir.
thank you very much, sir. Thank you very much. I have already given the concluding remarks. Thank you very much, sir.
Sorry.
You can close the session, sir. Thank you.
Okay, sir. Thank you so much for giving me this opportunity. I'm highly happy and honored to be here on this 6-day Atal FDP program. And thank you so much for this opportunity so that I can share my research to the participants. Thank you so much. And
Thank you,
thank you
sir.
so much all the participants to listen me for so long.
Thank you,
Sir.
sir. Thank you, sir. Thank you.
Okay, sir. Thank you.
You can sign off, sir. We have another session, sir. We can sign off, sir.
Okay, sir. Okay.
Thank you. Somab, sir, please make all the announcements regarding the test feedback and valedictory so that all the participants will be aware of it and join. Because today is the last day. All the participants, I advise don't be negligence because just within an hour or so we are going to close. And valedictory is very much important, and the test is also very much important. Feedback is also very much important. So kindly participate in all this, and let us close the session in a very good manner. Thank you, and all. Sombabu sir, please go ahead.
So just wait 2 minutes. I will upload a feedback link for this today in the WhatsApp group and as well as in the chat box also.
Okay. And what about the feedback to be given in the website, sir?
Sir, we are not uploaded attendance for the few participants. We are working on that.
Okay.
Uh, for those who are completed their attendance, please fill the feedback in the ACT portal.
Okay. So that means tomorrow also they can provide?
Yes, sir.
Okay. Not immediately. Tomorrow also they can provide feedback in the ACT portal. Okay. Exam and all, exam?
Yes, sir. Sir, dear participants, uh, thank you
Please make
all for
your
being a
voice
part
is
of
breaking. Please
the
make all
final
announcements.
session. Thank you for all the participants for participating on the final session of FDP. We hope you find the session valuable and that it has helped to wrap up everything we have learned throughout this journey. Your active participation and engagement have made this program a great success. We truly appreciate your contribution and hope you will apply the knowledge gained in your academic and professional work. We hope you find the final session insightful and engaging. Now, as part of this program, completion, please follow these steps. First of all, you have to attempt online test available on the ACTE Atal portal. The test consists of multiple choice questions and must be completed within the given time, nothing but 45 minutes. You have 30 multiple choice questions, and you have 45 minutes. After submitting the online test, you have to submit feedback on the ACT portal also. And after the submitting the feedback, we have valedictory at the time of 7:30.
Sir, your voice break.
So
Your
all of
voice
you be
breaking,
there.
sir.
Sir, we have valedictory at 7:30 p.m.
Okay. Some of the participants are asking me or chatting me that can we submit feedback tomorrow?
Sure,
And can
sir.
we write
No
test
problem.
tomorrow?
Sure,
Can we write test tomorrow?
sir. Please attend the test at the time of 6:30 p.m., sir.
Uh, so test is only today only we can apply write the test.
Yes, sir. Yes, sir. And
Tomorrow not
there,
possible.
there will be no problem, sir.
Okay.
Okay.
Right, sir. So are you closing, sir, now session?
Thank you all.
Sombabu, sir,
Sir.
shall I leave?
Okay, sir. Leave, sir. Thank you.
And I will join at 7:30, sir.
Okay, sir.
Excuse me, sir.
Thank you.
Sir.
Thank you. Yeah, go
Sir,
ahead, sir.
excuse me, I have a doubt, sir. Can I ask a doubt?
Sure,
Yeah.
continue.
Sir, I have attended all sessions, sir, but in web portal it is not displaying it.
We
It
are
is not
working on
allowing.
it. We are
Yeah,
we are
actually,
working on it.
wait.
Sir, within
I'll-
actually our online exam will start at 6:30 p.m., sir. Within
Okay.
1 hour, we also complete the attendance details because the session is completed this time only because so we have 1 hour to upload the
Data.
attendance, sir. So that's very
Okay. Okay. Right. Thank you.
Thank you.
Thank you, Randall. Thank you.